thank you for the very nice event they are organizing. Thank you for making history, for organizing the first Student and Young Professional Congress in Nairobi. It's my first time. I'm originally from Africa. I'm from Tunisia, North Africa, but I never been to the happy part of Africa, so I'm glad to be here in Nairobi. This is very serious. So I'm wearing two hats. Here I'm basically representing MTTS, so I'll do a short presentation about MTTS. MTTS is a continuous supporter and funder of IEEE Young Professionals in Space. So I'll do a short presentation about the MTTS, and then I will talk about IoT and the integration of non-terrestrial network. Just making sure, so am I still having the 30 minutes, or you want me to go? Okay, so as I said, I am on behalf of the IEEE Microwave Theory and Technology Society, MTTS. MTTS is a very known technical society in IEEE. If you don't know like the IEEE MTTS, or you are not a member, please reach out to me. I can talk more, but here we try to capture, I'll try to capture the, basically the area of interest and the current administration and the activities, and promote two main activities of MTTS. So we all know about artificial intelligence, and artificial intelligence is becoming part of all areas of engineering. So this is a recommendation for students to take courses on machine learning, and artificial intelligence becomes like a very important tool. So it's not a goal in itself, but it's a tool that you need for your research. Independently, if you are working for academia or industry, we need that tool. So there is also the interest in quantum technology and semiconductor technology. All of these are part of the fields of interest of MTTS. Okay. So the ADCOM officers are here with Gutham, our president, and the president-elect, secretary, and treasurer. So this is not working, yes? Or is it working? Did you put the adapter? Okay. Thank you. This is 2025, these are the 2025 committee chairs for award, budget, education, and so on. I can also share these slides with you if you are interested to know more about the team. We also have, please if you can go to the next, yeah. We have the MTTS YP committee, but with Valentina is our chair, Dr. Anis Ben Arfi is the vice chair, and we have also Sarah Barros. So these are very active people with MTTS for many years. The main actions that we have and positions available for you if you want to volunteer. We have social media and dissemination activity. We also provide events funding. So if you are organizing an event, as a matter of fact, IEEE MTTS is a big supporter of IEEE YP in Space for several years now, and we are proudly a sponsor of this event. We also have two main initiatives that I want to promote during my presentation today. It's the Outstanding Young Professional Lecture Program and the Student Ambassador. So any one of you as students, you can be an ambassador for IEEE MTTS, okay? For logo and social media, if you want to organize an event and use our logos, we provide you with these resources. And for the events sponsored in 2025, we sponsored several events in 2025, from Women in Engineering event to YP event to technical events, conferences, and so on and so forth. So IEEE YP Space is one of also these events. These are selected photos from events we organized in different places in the world, and with selected basically capture of the event with many attendees. Okay, same here. The two programs I want to promote more is the Outstanding Young Professional Lecture Program. Usually technical societies, they have distinguished speakers. And these distinguished speakers usually are professors in university. They can go from university to university, present technical things. The same thing is the initiative is to make this program for young professionals. So if you are a qualified young professional in your area of interest and you want to become, a lecturer, and you become, you want to share your knowledge basically, then you can apply to this IEEE MTTS Outstanding YP program. We have also next this is like the selected photos, and we also the student ambassador program. This is very interesting, kind of program. A student ambassador program exists in many technical society, and the main idea is you'll be representing your university or your section as an ambassador, and you'll promote activities. You'll have early knowledge to funding opportunities, and this is great for you as a student to network, to take some leadership positions, because this is what matters, okay? Yes, in school we go and learn about, the material, math, physics, and so on and so forth, machine learning and microwave technology. But what matters the most is your network, your ability to communicate with people, to take leadership positions. And this is, as our friends say, this is very serious. Don't take this leadership position for granted. This is very serious, okay? So this is about the IEEE Student Ambassador Program. I will share also the slides with the organizers. It can be shared with all students and participants. Next, please. And we add the students, this is like the quick update for, we add student application platform. This is for the ambassadors. And we have already accepted 71 new student ambassadors from different regions. These are projects organized by young professionals, so we encourage young professionals to be active and to be part of our society. Next, please. We have also something very interesting is the continuous education. Continuous education, if you want to take more courses that are extracurricular and you want to get more knowledge in different areas of expertise, then you can go through the Distinguished Microwave Lecturers and Speakers Bureau and get knowledge about these online webinars, seminars, and distinguished instructors. Yeah, I think that's mainly it. I will move now to my basically technical presentation. It's not very technical, but there is good, learning outcomes. It's very relevant. While waiting, it's very relevant to the event, but while waiting for the slides to be shared, the second set of slides, the MTT, like the PPTX. So while waiting for that, I have advice for students. Don't limit yourself to one technical society. Because, myself, for example, I have been active with the IEEE Communication Society for more than 15 years. But I am also very active with IEEE GRSS, MTTS. For AESS, the organizer of this event, I've been serving as a moderator, and also there are student competitions. So I was a judge for many years, and I do encourage that you have this general expertise, general knowledge, because it helps a lot. Okay, it helps a lot for your career. Don't be only focused in one area, because these areas are already related. If you talk about space, you need to know about the frequency, you need to know about the antenna, that's why APS knows, you need to know about sensing, that's what GRSS comes. So again, I didn't introduce myself properly. My name is Ziad Bouida. I am an IEEE senior member. I've been active with IEEE since 2008. And I took leadership positions. I was the IEEE Canada Young Professional Chair, and I received multiple awards because of my involvement. One of them is the award in the Sensor Council. I received the Young Professional Award in that. I'm saying this to let you know that you don't do only volunteering for volunteering and learning only, but you'll get many awards along the way when you volunteer. Now, my presentation will talk about key communication enabling technology for disaster response and preparedness. This is a very interesting topic. When we talk about disasters, especially we live in a time that disasters happens more frequently. You know, fires, earthquakes, wars. We are kind of unlucky to be in a time that where people are fighting all the time, disasters coming. So it's not a pessimistic view, but we need to be prepared because unfortunately, wildfires, you heard recently of wildfires around the globe, Los Angeles fires, so many disasters happens around the world. Now we as engineers, how can we help being prepared for such scenarios, for such disasters, okay? So please, I can use this one, yes? Very good. So my outline, the outline for my talk will be as follows. I'll start with an introduction, okay? Then I will talk about the post-disaster key communication enablers. I will shortly discuss the IEEE MOVE program if you don't know about this one. And how can we raise the awareness about disaster preparedness, okay? So I'm working also on selected research for integrating non-terrestrial networks. And I'll talk about that very quick. Now, how does this topic relate to the event? My main focus for resolving disaster response is to focus on non-terrestrial network. Anyone knows about non-terrestrial networks? Can you help me with the answer? What is non-terrestrial networks? My friend, they are not focused with me. So what should we do? Yeah, so non-terrestrial networks or technologies are technologies that are not developed on the ground, okay? Who can give me example of non-terrestrial technologies? Starlink. Starlink is a type of satellite constellation. What type of satellite constellation is that? You know, there are different levels of satellites, yes?
Low orbit satellite?
Exactly, low orbit satellite, which is the LEO. There is the geostationary, and also LEO. So there are different layers of non-terrestrial network. And this is within the area of expertise of IEEE AESS. And also it has a lot of related communication to bring ComSoC, antenna propagation, GRSS, sensing. So my presentation will raise the awareness about the importance of being prepared for disasters and also what are the enabling communication technologies through space. I'll focus on space technology. There are ground technology like the IEEE MOVE program, which is a track moving from place to place, trying to resolve this kind of disasters or help with this type of disasters. So communications during disasters such as earthquakes, floods, or military conflicts is crucial for saving lives. It's all about saving lives, okay? So life of any human is very important. So we as engineers, like the medical doctor, they do the surgeries, but we provide the technology to help, save lives, okay? There are some terms, it's called the golden hours, the 72 golden hours. When a disaster happens, the time frame that you are able to save most of the life or more lives is the first 72 hours. They call this the 72 golden hours. And the main idea is to provide effective communication within those golden hours. There are several challenges that comes. When we talk about a disaster, anyone can mention an example what happens during disaster? The towers fall down, communication towers. So you don't have network. Power is cut, no power. So it becomes a very challenging environment. So if you don't have power, how can you communicate? It becomes very challenging. And this talk will raise the awareness. And actually, this is very important research topics. Either research or industry, wherever you are coming from, you need to, when you attend this kind of presentation, first of all, don't be on your phone, sister. And second, just to be focused. This is what I say to all my students. Unfortunately, the students these days are fortunate to have, a friend, which is the phone. At the same time is an enemy because it makes you distracted all the time. You are listening to the presentation, this guy was talking about disaster response, and you go to WhatsApp, and then you come back, and you become distracted. But if you are really focused, and I love those who take notes with the pen, because that invention, the pen is not used anymore. Many people don't know the pen. The new generation, they don't know pens. That's why in some Nordic countries now, they forbid all technology within the class. So please be focused. And when you attend such presentation, don't attend just for the sake of, oh, this is text ongoing. See how can you contribute, what can you learn, what tools do you need to be able to work in this area, and that's basically provided through many technical societies. And third, how can you think to implement this in your own way? How can you contribute, either incremental contribution or something, novel? So this way we can make a change. So there are several techniques or challenges. There are several challenges that happen during a disaster, including the destruction of the cellular infrastructure, communication. Electricity infrastructure can be gone for earthquakes. And there is a lack of line of sight. What is line of sight? Sorry, good name? Noah. So for example, I am now in line of sight with Trevor, okay? Sorry, with Noah. That's a bad joke. Are we recorded? Don't cut this afterwards, okay? So I am in line of sight with Noah. If I send something, most likely it will get to you. So we are in visible and radio line of sight. But let's say if, God forbid, something falls, that I'll be in this half of the room, you're in that half of the room, we don't have line of sight. And this is more challenging. So what worked before for line of sight, like let's say if you are using free space optics, that works in line of sight. But if it doesn't work, you need to go to another communication technology like radio frequency communication. Okay, so you need to adapt, or you need to provide solutions that adapt to the disaster. So you don't get restricted to one technology. You can use multiple technologies in order to accommodate the scenario. Localization is a very challenging topic. If you have someone within the room right now, you can localize it easily through some technology. But let's say if someone is under the rubble, how can you locate someone under the rubble? It means after the disaster. Okay. Again, we'll continue here. What is important, we need a timely and accurate information dissemination. It means when first responders come to save lives, they need to have, information about the environment. And this is where the XR comes, the augmented reality. When you provide these people with knowledge about the place, about the location of people, about how many people are alive, are there any response from how serious is the situation, are there any gases? So this supporting information is very important. You need also to enable a clear, concise messaging, because this will help relieve the panic. So let's say if you enable a communication technology with the people that are in disaster, then it will be more comfortable, okay? More comfortable for these people, at least to be, ensured that help is coming on the way. The integration of localization and sensing mobile technology further facilitates the search and rescue operation. So Professor Sabrina, yesterday for the IESS chair, she mentioned about the integrated sensing and communication. This is a very interesting research topic also if you want to work on this topic, the ISAC. So please take note of the ISAC, ASAC. This is a very interesting topic, and it will be part of the 6G. As we know, communication, they have generation. We are in 5G now, but we are doing research for 6G. And 6G, part of the talk, will have a big influence on a big implementation or integration of non-terrestrial networks with terrestrial networks. So also, boost communication during disaster, satellite and aerial platform redundancy. So these are key technologies that can be used. Satellite and aerial platforms is communication through drones. For example, you can use drones for communication. You can use, this is for low altitude platform. There is the high altitude platform, it's called HAPS, H-A-P. I'm not sure if you know about HAPS. This is a boosted technology. This is, again, a very interesting area of research, HAPS. And there are, after that, the satellites with the LEO satellite and the GEO satellite. Okay, so I recommend that you get informed at least about this architecture. Redundancy. What is redundancy? Anyone can tell me about redundancy? Backup. In every airplane, you find two engines. If the first engine stops, then you do the second. If the second stops, just do the prayers. Okay. God forbid. I mean, unfortunately, many of these accidents happen, you know, from the 737 MAX to the recent airplanes falling. And this is mainly probably software engineers are not very focused when they do their program for the airplanes, but disasters happen, you know. So silencing. Silencing is another technology. Silencing, when the infrastructure is destroyed, it will be in the benefit of the provider of the telecom, you know, the provider of connectivity, to shut down some of these base stations to make sure that no interference happens. This is called silencing, but we will not go in the details. One important topic is the wireless energy transfer. Wireless energy transfer. Anyone can tell me what wireless energy transfer is? So let's say I'm in the middle of a disaster. I'm stuck here. I'm stuck here. My phone is here, and I don't have power. So how can you charge my phone remotely? Yeah, this is the power transfer, either through, you know, kind of free space optics or any type of RF. There is a big, you know, research that was done on energy harvesting, and this is boosting. Now, they basically did many successful experiments with very, you know, efficient power transfer. So imagine people are in a disaster area, they need communication. So what you can do is do this wireless energy transfer. This wireless energy transfer can be also done underwater. So there is a lot of research areas for this wireless energy transfer. So let's start with aerial platforms. Aerial platforms, for example, UAV provide real data collection and situational awareness. Very important. If you have a disaster, when you deploy the UAV, you have access to cameras, you have access to sensors, you know the place that has fire, you know the place that doesn't have fire, and you are able to classify these areas based on the level of you know, the emergency. And then this will provide information to the rescue teams, and the rescue teams will plan accordingly. For example, if you have you know, areas where there are kids affected, you are able to rescue these kids in a very efficient way, okay? So this is very important when it comes to saving lives and to prioritize. This is through UAVs. Both UAVs and HAPS can act as a flying base station. Okay. Flying, what does it mean, flying base station? What is a base station? What does it mean, a base station? When you have the infrastructure for communication, for the network, we have the phones, but these phones will need to communicate with these towers. You know the towers, yes? The tower is a base station. So we have areas, we have ground base station, but we have also aerial base station. Now, this type of UAV, some UAVs, I will show you, for example, of FirstNet. FirstNet, you know, anyone knows FirstNet? FirstNet is in the US. They have this first responder network for first responder. They have their own network built by AT&T. They call it FirstNet. So you can use this UAV or HAP at a higher level to serve as a base station. Okay? A UAV network can communicate with the mobile devices of impacted individuals using the exchange of signals and received signals strength. So based on the exchange of signals, you can know the quality of the channel between the disaster area and the UAV, and then you can plan the communication accordingly. Wireless RF sensors have several advantages, as they can go and see through walls and rubble by detecting reflected waves. So the use of RF in that case, because of the reflections, you are able to locate people, you are able to communicate with people in an effective way. This is a good architecture. I will spend a few minutes on this. So you can see here, let me see if this is, will work for me. Laser, okay. No problem. I think, can you enable the laser for me from the bottom? There is like the pointer. There are the 3 circles. No, not the circle, yeah. Else it's, yeah, or probably, that's fine. So what you see here, you see the disaster area, yes? The bottom. The disaster area, it can be in the sea, it can be on the ground, it can be in any location. So what happens is how can we enable these different level of space technology on non-terrestrial networks? You see a UAV is enabling communication with the mobile. It can also used for WET. You see the arrow, the red arrow? So there are 3 types of arrow. The blue one is for data uplink. It's data communication between the disaster area. If we are in a disaster area, we need to communicate with the world, else we'll be in Gaza, okay? The second way is WET. WET is the wireless energy transfer. Wireless energy transfer is when you are charging these mobile phones using the aerial technology. And also you have the backhaul. The backhaul, basically, when you're collecting this data, you need to send it to the network in order to make decisions, in order to take actions. You have on-demand WET station. This track is similar to the, I encourage you to read more about the IEEE MOVE program. There are tracks, they go to the disaster area, they provide connectivity and also provide charging for mobile phones. So this backhaul can be through a hub, which is the balloon. The balloon is what referred to as the hub. It stays in the stratosphere and it's providing connectivity, okay? And if you cannot provide this technology, you can go through Elon Musk, Starlink. There are also other examples, successful examples. And amazing, you know, enough, in some airplanes, even from Nairobi, you travel to Emirates, Doha, or other parts of the world, you will have full Starlink connection. You have very good internet on the airplane. It's better actually than the ground. I tried it. It's amazing. So now Starlink is very successful in providing internet connectivity. So this is also a very good, successful example. But either other than the LEO, you have the GEO satellite. The GEO satellite have more coverage. Unfortunately, it will come with some price to pay. It's latency and lower throughput. So every layer has its advantages. I'll finish in 3 minutes. I have three minutes. I don't have control now, but no problem if you can change for me, please. Oh, it's coming back. Okay, so wet technology, the wireless energy transfer, it depends on the environment. So if you are in underwater, you use acoustic wave. So I'm not sure any of you is interested about the underwater communication, but it's a very interesting area of implementation and research using acoustics. The wet provider can be a hub. It can be an automated, underwater vehicle, or bring your own station. BUOY, B-U-O-Y. I can also share these slides with you. Is bring your own station, bring your own solution. Environment, if you are in mountains and rubbles and no line of sight, so you have inductive and use of RF. If you are clear terrain and line of sight, optical like laser, free space optics, microwave, and RF can also be good technologies. FirstNet as an example is the network. What they use a lot of these flying cow. The cow, you know the cows. Anyone know the cow? What's the cow? The cow is not the animal in this case. This is the cell on wings. Cell on wings, they call it cow, flying cow. It's a cell on wings. So these are like some information about the network. These are examples of the flying cows and these SAT-COLT, which is the vehicles similar to the IEEE MOVE tracks. They move from place to place to provide connectivity. And this is an example here. I hope it will play. Can you press enter? No, it will not play, but that's not an issue because... So basically, these guys are setting a cow, a flying cell on the edge. It will fly and provide connectivity in a place of a disaster. Okay, And this one is a cell on edge. It's equipped with the tools to enable not only communication, but also to serve as a base station. Okay. Next, please. Raising awareness for disaster preparedness. We have been conducting part of many technical societies, including GRSS, APS, MTTS, many events for, this is an event for amateur radio for students to enable this kind of communication in a disaster response. We move from young people to old people, and here we have the IEEE fellow life members, who are designing antennas. Next, please. We have also some rescue humanitarian initiatives. I encourage you also to be part of humanitarian technology. We have the humanitarian initiative, the HIC, we have the site initiatives. Try to be the good part of this world, because don't try to be on the side that you build the drone in order to go and kill people. Try to build the drone to deliver medication. Don't be evil, please. Don't be, I don't change the scope of the topic, I'll deviate, so you got my message, I guess. Don't put that, okay. These are also a lot of workshops, amateur radio field day, and I'm exactly on time, so if, I'm done. Thank you very much. A very nice question, actually. This comes to the idea of heterogeneity. Okay, heterogeneity. Even our phone right now, it has Bluetooth, it has Wi-Fi, it can work with 2G, 3G, 4G, 5G. All of these phones are enabled with multiple technologies. So we don't want, actually 6G, good news for the 6G, we are targeting the phone to work directly with the satellite. So you don't need to switch the phone to go, because one of the main problems with the previous technologies with satellites, that like the Iridium and so on and so forth, you need to change the device. If you are a fisherman, you go to the sea, deep in the sea, or you go to the desert, you need to change it. Specifically if you go to the safari, probably if in some places, I'm not sure about Masai Mara if they have like good connectivity or so, but in these type of areas, you need to change the device. Now the good thing about these new technologies is they allow the heterogeneity. So in case of a disaster, we need to enable either these tracks or drones or satellites to serve different ways of technology, like hybrid technology. For example, I am enabled with free space optics to communicate directly with you, but let's say if there is no line of sight, I need to adapt accordingly and use a different technology. So this is mainly the idea of heterogeneity, and a very nice question. Thank you so much. Okay, I'm available the whole event, so yeah, let's open the room for questions. This is... yes. Thank you.
Yes, good morning. My name is Alan Omari. I'm an aeronautical engineer by trade. I've been active in the aviation industry for 10 years now, working in all sectors, general aviation, and now I'm in the Ministry of Transport, State Department for Aircraft Accident Investigation, and we do basically what the name says. We investigate aircraft accidents. I remember, maybe just to recap, I remember the 2 times my parents watched news during the day, and that was the bomb blast and when Concorde went down. And I knew about the Concorde from encyclopedias that I had had from when I was young. And when I saw the accident, the post pictures compared to the pictures of the Concorde in its glory days that I knew was so different. And that struck an intrigue in me. And so I was lucky enough to study aeronautical engineering in Russia and Ukraine. Came back, did my licenses, worked in the aviation industry for some time and was fortunate enough to join the department where I currently work. To get down to the root cause of the things that caused such things as Concord, and I've been lucky enough to be part of very interesting investigations. But when I got the call up today, I came up with an appropriate topic: cracking the code, how aircraft accident investigation saves lives. Globally, there are around 100,000 flights per day, all around the world. We can think, when you stand in Wilson, you'll think Kenya is busy, but there are countries that have really busy airspaces. Of course, we lead in the region, but there are countries that have very busy airspaces. In my experience, we have about 2-3 accidents a month, but there are countries that surpass that. There are over 500 a year, so that's more than 1 a day on average. And our main goal is to bring down those accidents to a very minimum. Of course, when you learn safety management, you'll know that it's almost impossible to bring down the number of accidents or to cut down risk to zero. But our main aim is to reduce it year after year after year. The sad thing about what we do is that we learn from failure. We don't come from a point of knowing something. Something has to happen for us to come up with a recommendation, but hopefully it will eliminate that thing from happening ever again. There are maybe 3 major causes of accidents in my field. Of course, the biggest is human factors: the pilot, the air traffic controls, the engineers. There are so many people, or we call them liveware, that go into aviation that makes it one of the leading causes. And it's leading by a big margin, maybe 60-70%. But the second one is hardware. Hardware will include both mechanical and electronic failures. And I think for the purposes of this discussion, that's what we are going to mostly focus on. We know that from the very early stages of aviation, everything used to be manual. We used to use cables. At the best improvements, we started using hydraulics, pneumatic actuators. But they come with many challenges. They make flying easier, but they are also heavy. You understand? When you take an example of an aircraft that's, say, 20 meters long, 30 meters long, and you try and plumb it, you know, you have to put hydraulic lines or pneumatic lines or cables up to every, I'm not sure if I'm talking to people who know about aviation, so yeah, up to every part of the aircraft, they become very heavy. So in the 1980s, they came up with a fly-by-wire system where only a signal is sent to an actuator that's only located at the part that is intended to be moved. So instead of moving it from the cockpit, it's just signals that are sent. That reduces all the wires and the plumbing that need to go, making the aircraft lighter, safer. There's, the things to go wrong are reduced. But this comes with another challenge. It becomes almost totally electronic. Nowadays, the aircrafts have gone into the electronic age, maybe even faster than we can catch up, because you find that, as we're going to see in some examples, you'll find that there are times that you invent something electronic, to, of course, make work easier, but you don't think about what are the effects they'll cause, because we all want to, make our aircraft electronic at a very fast rate. Things update online as the aircraft flies or as it's parking. It's crazy. We are going to see some examples that I've set out aside for you to prove this point, and we will then know how to combat them, and also the role that electronic systems play in aviation now, in the past, and in the future. There's types of electronic failures. They could be sensors. They could be software bugs, from the coding process, or even electronic wiring, like the infotainment system. Those things create a lot of incidents. I remember there was a Scandinavian flight back in the early 90s when infotainment systems are just coming into aircraft. A long time ago, people used to just get on seats and, I'm guessing, talk to each other. But they started putting televisions at the front of your seat. But they did not anticipate how much power is being drawn from the system. And it led to one of the crashes, because there's a time most of the people had put on their screens at the same time. That time, it was still, I think it was LCD, an older technology which used to draw up so much power, and it drew up so much power that the aircraft ended up having an in-flight fire, such things. As for sensors and software bugs, all of us know about the 737 MAX, for those who don't know, of course, we're going to visit it, but for those who don't know, Boeing, in an effort to compete with Airbus, came up with the 737 MAX. 737 is a family of aircraft that has always been there, but they decided to upgrade it. And one of the things that made the 737 very popular at the time, because it was the transition from propeller aeroplanes to jet-powered, was that jet-powered aeroplanes were so high, so they needed ladders and conveyor belts to load luggage and for passengers to board. So how did Boeing go about this? They put the engines very low to the ground, so that you don't need the jetway, so that stairs can just be brought and then you get off. And also for luggage, it would help because it doesn't need specialized equipment. And that worked for some time, and it was one of the best-selling aircrafts for a very long time. But time caught up, you cannot run away from time. So when Airbus introduced the competitor aircraft, Boeing decided to cut lines and also launch an aircraft or preempt a launch before they are overtaken by their main rival, which are Airbus. So to increase economy, they ended up putting bigger engines. But the big engines would touch the ground, so what do? You push them a bit forward and raise them up, and that's what they did. But it changed the flight characteristics of the aircraft, basically. So when you power up, the aircraft tended to pitch up. When you slow down a lot, the heavy engines that have been moved forward tend to pitch the aircraft down. And so they came up with a system. They coded a system that depended on the side of the aircraft. There's something called an angle of attack sensor that does what exactly it says. It senses the angle of attack, the angle to which the aircraft is in relation to the oncoming air. So, they did that, but because they skipped many phases, including R&D, whenever that sensor would malfunction, then the whole system malfunctions. You understand? And in aviation, that's not supposed to be the case. In aviation, we have double and even triple redundancies, especially for such critical elements. But they didn't think of that, and they'd become complacent. They put the FAA in the pocket, the ones who regulate them. And basically, FAA told them, yeah, just if it's good for you, then it's good for us. And we can see that's the failure of sometimes of the agencies that regulate us, but that's not the point. Yeah, so which led to two very serious crashes. One was for Lion Air in Asia, and the other one was sadly from our neighbors in Ethiopia. And it led to the grounding of the aircraft. And I don't know how far it is from recovering, but yeah, that's the short synopsis. I've already told you about the the 7.3 case. Basically, the system was called MCAS. MCAS misread, or they misread the AOA's angle of attack sensor, so it misread it, or the sensor was faulty. And basically, the sensor told it the aircraft is too high. You know, it's too high. So what do? Just pitch it down. So no matter what the pilots did to pull it up, the aircrafts are very automated nowadays. Sometimes it will deny you the ability to correct. So that is the case in both aircraft, because the pilots really tried to pull it up, but the aircraft in its own thinking knew that this aircraft is facing too high, so why pull up more? So it kept nosediving. So basically the aircraft nosedived itself to the ground. Two crashes, 350 people died. One of the biggest mysteries in aviation, well, not a mystery because it's solved now, but it's one of the biggest days in aircraft accident investigation, where we would see everything come full circle, from regulation to the complacency we talk about, to everything started making sense. Maybe aviation was too safe, and we needed this to show us what is possible if we even slacken a bit. I'm going to take you through investigation processes. Immediate response after a crash. What do we do in my field? We secure the site. Once we get there, this is a picture of the recent crash in Mwihoko. That's my colleague, and we are somewhere in that vicinity. We secure the site. By securing means, sometimes we do not have the manpower because we are only 5 in the whole of Kenya, and we have been tasked with the mandate of investigating. So by securing, we'll involve police, we'll involve whoever is there to help us secure, even if it means putting the yellow lines around the crash site to prevent basically intruders from compromising the site. The next thing is to preserve evidence. What does it mean to preserve evidence? Not necessarily collecting. We can collect perishable evidence, but if a site, you see, there are many different types of sites. Most of the sites that we get are remote, and we have time to mark everything and come and photograph. But the site like this one that happened in a densely populated area, it was very hard to control people. It was very hard to control people, and that led to perishing of evidence. When we went to collect, I think it was on Friday, when we were doing debris cleanup, we could only get maybe a small pickup worth of debris. So we thought all of it was disintegrated and, we'll never find it. But yesterday I was at the police station. They had called us to pick some things. And lo and behold, what do you find? So much wreckage that people had collected. But because we are told the scrap metal dealers not to take any aluminum from the flight, they turned them down. And that's why those people brought it back. So you can imagine between the time we couldn't secure the site when people were still on the site, those 2-3 hours led to people looting of so much valuable evidence that they were only being returned yesterday, and now in large numbers, because now no one is buying that scrap metal. They had already taken them, and now it even filled the lorry. That's how much was looted. So that's the importance of securing the evidence, the crash site. In cases where there are survivors, or they are suspected to be any survivors, the next thing before we even start is search and rescue. Of course, lives come before anything else. But as a rule of thumb, if you go to a crash site and you deem it to be unsurvivable, accident investigation takes precedence. Well, we go to, after securing the site, we go to evidence preservation. Evidence preservation can include marking debris field, as I was telling you, just going and putting maybe a yellow flag on where there's an aircraft part, a red flag on where maybe you suspect there is biohazard. By that I mean human remains and all that. You photograph wreckage. It's a course that we are taught to do. It's very specialized. And collect perishable data. By that I mean things that can be tampered with. One of our first, as you'll see as you're going, one of our first things that we look for are voice recorders and flight data recorders. They are usually called black boxes, but as many of you would suspect, they're not black. As you can see, this is a crash of, I'll come to it, but I was trying to explain how we mark out debris. We can use a drone to just go up and capture the general outlay. An aircraft is a big thing. Like that is an ATR 72. If you say you're walking wing to wing looking for debris, you can even miss some things. As you can see, some things can be in the bushes, but once you get the drone up, you're able to even locate the four corners of the aircraft. You can see them, the tail, the wings, the nose. And as the drone comes in, you can be able to figure out what's what. Forensic tools in investigation. As I said, there is wreckage analysis, black box decoding, and radar and weather data. Wreckage analysis is exactly what I've shown you. This is an example of a black box flight data recorder. It has different parts, as you can see. It has a lot of, I'm saying as you can see, and I'm seeing in my screen. Basically, it has an underwater locator, the cylindrical thing outside. When it comes in contact with water, it starts pinging at a certain frequency that is detectable by equipment or sonar for up to 72 hours. As you can notice, a black box is geared to survive a lot of abuse, basically, G-forces and heat specifically. And this is the truth teller to us. So when we get to a crash site, this is one of our main things we look for, because it tells the whole story without bias. Yeah, as I mentioned earlier, there are two types of black boxes. Okay. There are two types of black boxes. Flight data recorder and voice recorder. Flight data recorder and the cockpit voice recorder, again, there's no mystery. They do exactly what they say they do. Flight data recorder records all parameters of flight, depending on the company, but they record all parameters of flight. These are some of the examples: the engine speed, the fuel consumption, the landing gear position, if they're up or down, flaps position, aileron position, radar position, so many elements. These are just some of it, and this was the initial stages. Nowadays, they record up to thousands of detailed information about the aircraft, the altitude, latitude, temperature outside, temperature in the engine, temperature in everything they record. Cockpit voice recorder records voices in the cockpit. There are microphones around the cockpit. So it can record crew-to-crew conversation. It can record crew-to-ground conversation. And then, even more importantly, it can record sounds that you hear around the cockpit. You know, sometimes you can suspect it's an engine failure, but there's no concrete proof. You don't know what happened. You can sometimes listen to the cockpit voice recorder, and it will tell you from the sounds what the engine is sounding like. If you hit something, it will pick it up, and we find that very useful in my field. Radar and weather data is one of the tools, again, we use to get to the bottom of what happened. Radar and weather satellites send such images, and these images, we don't access them, but our partners in Kenya, for example, it's the Kenya Civil Aviation Authority through Air Navigation Services. They have radar and satellites that they are able to access this data and send us to our request. But it's also available to pilots. Before as they are doing their planning, it's available to them. An aircraft also carries a mini weather radar, so it can scan its environment and know where they're expecting bad turbulence, so whether to divert, whether to change configurations of the aircraft, you know, many things. If you're expecting thunderstorms, you just go around them. If you're expecting a lot of rain, there are aircrafts you can just select to put on the igniter plugs to continually, you know, glow, so that spark, so that you can never extinguish the flame in the combustion chamber. So there are many things to that. The radar helps in flight tracking also. As recent as 1998, we started, the weather radars were updated to give wind shear warnings by comparing different wind speeds at different places to predict a possible wind shear with a certain degree of accuracy. So I've given you the basics of accident investigation. Now let me tell you why accident investigation saves lives. There are processes to accident investigation. As I explained from the beginning, once you start, you prepare the investigation team, establish facts on what happened, identify immediate cause, identify underlying cause, identify remedial causes, investigation report, follow-up. So after you establish what happened, in the middle there, between identify what happened and identify immediate causes, there is a preliminary report that we write that's supposed to be out in 30 days. Before we get to the investigation report, that's the final report that is usually out after a year, and if not possible, because there are investigations that might never be closed or will take a long time. Many of you ask how. Investigations are ongoing until you find the cause. So once you have not found the cause, then the investigation is ongoing. An example of Malaysia, the Malaysia aircraft that disappeared. That investigation is still ongoing. That's an open investigation until we can locate it and find out what happened, where it went. That's ongoing investigation. How many years later? Close to 10, more maybe. So an investigation can go on for however long is necessary. But when everything is available, we try and close it fast. Again, to come up with safety recommendations to prevent that same scenario from repeating itself. Accidents will happen in many ways. There are accidents during landing, but not all circumstances are the same. As we say in aviation, every case tells a different story. It can be the same, just a little minute thing, and those minute things are what we keep eliminating. So that, is it this that happened this time? Then what is needed? Train crew better, do this, do that, yeah? And basically that's how it improves safety. In the early 60s, in the early 50s and 60s, when the jet age was coming along, the World War II was done, and now every aircraft that was used in the war was being used to shuttle passengers, and the jet engine had been invented by a German scientist, but the publication was taken by Americans. They perfected it and came out with the first, them together with the British came out with the first jet engine. Of course, even the Russians did. So the first jetliner was called, before the age of Boeing and all that, was called de Havilland Comet. The de Havilland Comet was impressive. 4 engines, all in the wing. They were not exposed. I don't know if anyone knows the de Havilland Comet. Very beautiful aircraft. But because they didn't know better, they put the windows to be square, yeah? Because all the aircraft had square windows, so why not have square windows? We lost almost 4 de Havilland Comets to accidents, disintegration in flight. Before accident investigation branch, aircraft, they are called AIB, came in to really look at why these aircrafts are falling from the sky. And they found that it's the design of the windows. They cause concentrated stress. That would not be possible if it was not for accident investigation. We can lead to new regulations if we find something that is totally amiss. In the early days, pilots were mavericks, and they could fly however they wanted, whenever they wanted. Some pilots were said to have flown 18 hours straight or without sleep, and they were considered heroes. But there are some accidents that happened in the 60s and 70s that prove that crew fatigue is a real thing, and that all came from accident investigation. Nowadays, the rules are changed. At least for my country, a pilot can only fly for 105 hours a month. So that incorporates rest and all that. I'm almost done. Now, have you ever wondered why there are aircraft that land in other countries and they are refused landing in others? Why was it a big deal when Kenya Airways started going to the States? It's not because we didn't have aircrafts that could go. Why do you think it was a big deal? Hmm?
Probably the windows in the airport does not support the sound of the airplane.
Yes, it's a good try. No, we are all under, yes? Yes, basically. We are all under an umbrella body, under the Chicago Convention called ICAO, International Civil Aviation Organization. We are all signatories. When I say we, I mean Kenya as a state, signatory members. And ICAO comes up with the rules, recommended practices, and standards and recommended practices that all countries should follow. And what is the benefit of that? It makes sure that safety has a universal baseline. Not that Kenya is safe according to Kenya. Yeah? Not that Kenya is safe, but in comparison to Uganda, no. Not that, like the olden days, we knew that only the Europeans and maybe the Americans had the best safety records. But after ICAO standardizing safety, we realized that all of us fall in the same category. It's no longer about superiority. It's about, if you don't practice safety culture, it will always come and bite you. The accidents that were happening in Africa were the same ones happening in America and Europe, if not worse. You see, the olden days they had pushed a narrative that, oh, you guys are unsafe, you don't know, we know. No, but when the standard came, ICAO brought a standard that they keep updating it day by day. And once you comply with those standards, then you are allowed to go to other countries knowing that they have the same standards of safety. Yeah? So the American planes and European planes land in Kenya, and Kenya goes there knowing that we have the same, or we are there to the same strict standards and recommended procedures set by an international body. You see, once you go below that, what happens is most of the countries even ban you. They tell you you can't fly into our airspace, you're not safe. And that's where we are. We are now at an age of safety. So the role of AID basically is to keep the same standards of safety that will attract or maintain other countries to feel like they're safe coming to our airspace. Because once they feel like we don't get to the bottom of issues, we don't give safety recommendations, then they will be wary to come to our airspace. Now, I think I've yapped a lot, and maybe I give you a few examples of air crashes that have happened, and I've narrowed it down to the last 1 year. Yeah, I'll give more for other years. There are many. We can't finish all the accidents that happened, but these ones are the major ones that caught public attention. This year there was Air India. I think it's the most recent. And we cannot speculate on it, but the initial preliminary report is out. So basically, this is an aircraft that was taking off from India to the UK, and a few seconds after takeoff, the engines were shut down. As to who shut them down, no one knows. No one knows. Because the pilot is hard asking, are you the one who shut down the engine? One of the pilots, we can't know which one. And the other pilot responded, no. So it's very early to speculate. In my line of work, we don't speculate as to what happened, but basically it led to the loss of very many lives, with one miracle survivor. But as I indicated earlier, we are moving at a very high rate of speed in terms of trying to make everything electronic in the aircraft, that we forget simple redundancies that were done with the same electronic systems. This would have easily been prevented if there was 1, 2, or even 3 more modes of making sure that the aircraft engines don't go off no matter what. Because the aircraft knows when it's time to take off. It knows when it leaves the ground. It knows that you're on full power. It knows your angle of attack. It knows your destination because you've fed it. So this is something that would have been preventable if there was multiple redundancies to that. But this has never happened before because there's never a day that the engine have shut themselves down. Because on such an aircraft, there is something we call a toggle switch. A toggle switch is a switch that has to be lifted to be put down. And all along we thought there is no way an electronic system can shut itself down because this is a manual switch. So it will be interesting to see if at all no pilot touched the switch, then how come the aircraft went down. There is the case of the Jeju Air, which is a South Korean carrier, one of the largest. It happened in South Korea. On coming to land, the aircraft ingested birds. Yeah? So it did a go around. On coming to land again, because one engine was seriously wrong, the pilots decided to shut it down. What happened when they shut it down? They shut down the wrong engine, the one that was working properly. So they lost the hydraulics that were supposed to put down the landing gear. They lost a lot of things, and this made it belly land. When you belly land, the traction is considerably less, and and they ended up crashing into a barrier at the end of the runway. What do we learn from this? I feel like the designers of the cockpit should, because the cockpit has been like that for ages and nothing has ever changed and nothing has ever gone wrong. But you see, this is almost the 3rd time in the recent maybe 5 years that an engine has been inadvertently shut down. It means it's something that could happen again. And there has to be interface clarity that prevents you from shutting down the wrong engine. I'm not sure how. I'm not in that line of work anymore. But yes, so interface clarity. For those people who are going into electronic and all those engineerings maybe related to aviation, this is a way, maybe a challenge that you can solve. Huh? That is basically the cockpit layout of an aircraft. You can see where you can't see the shutdown of the engines, but they are way lower than the engine controls, just lower than that. So that's something we might need to solve. There's another case that happened earlier in the year of an Azerbaijan Airlines, an Embraer 190, that was shot down, allegedly. Yeah, you have to be careful with such suspected missile attack. This now comes to, because this has been happening more often. You remember the other Malaysia, was it Malaysia aircraft that went down in Ukraine? Yeah. There were 2 that year, one that disappeared. There's one that was shot down over Ukraine. We have a Kenyan registered aircraft that was shot down in 2021, maybe 2022, I'll have to confirm, in Somalia. And these things keep happening in war-torn areas. So there is need for threat analysis. For those, my previous speakers spoke about AI. How then can you balance between knowing which is the enemy aircraft? Yeah, because for the two that happened in Somalia and the one in Ukraine, the enemy actually thought it was an enemy aircraft. They didn't lie about it. They were like, yeah, we shot it down. But we have said before you come, tell us. You can't just pass without telling people. There have been many, oh yeah, I've remembered. There's one that the Americans shot down in the early 80s. There's one that the Soviets shot down, again, when they invaded the airspace without knowing. So many things are going on. And that's where AI comes in. I think we are at an age where if humans can't identify, then AI is the best. There is the case of Delta that carried it off the runway. It flipped on landing because the landing gear was suspected to have failed, as you can see, and careened off the runway. Those are some of the serious incidents that happened this year. And the chief culprit is basically maintenance, but we're yet to know because it's too early. The NINI is not yet out, the final report. I think last but not least, there is the Veopass ATR 72. This was carrying doctors, if you remember it, in Brazil. For those who are aviation enthusiasts. It was carrying doctors, but it ended up falling from the sky. There's even videos of it. And on going to closer inspection, it was found that it was due to ice contamination on the wings, and it could not generate enough lift, and it led to a flat spin, and people lost their lives. Very well-known doctors and going to do noble work. And electronic systems can help us there because this is a problem that has been plaguing aviation from when we could go high enough to form ice. We have had ice-related accidents. So far, they have done de-icers and anti-icing liquids and equipment, but clearly it's not enough. There has to be a way because there is something called black ice that is very, contrary to popular belief, it's not black, but it's very hard to detect. It's clear. You look at a wing and you can't know there's anything. It's like glass. And that's what leads to many accidents. So for those who are into the electronic thing, maybe that's one thing. I don't know why no one has come up with a system yet to figure that out, but it's a challenge to all of us. As I wind up, maybe let me talk about, I'm not sure how many people here are aviation enthusiasts, but if you have not done engineering or piloting, there are still many areas that you can come in related to aviation safety, air traffic controls, technology and innovation in aviation. It's a very lucrative business of late. Aviation management, you can come up with many solutions that many people have not been able to see. So as I wrap up, every accident tells a story, and every investigation writes a new chapter in safety. That's what I want you to take away from this. Thank you for listening. I hope we can all continue to be safe in our skies. And maybe last but not least, I think my time is up. If there's anyone with a question or an addition to what I've said, they're welcome. I'm seeing one person, 2, 3, 4, okay.
Okay, for clarity, maybe...
Thank you. I may not take up much time. Let me start in that hierarchy in chronological order. Warren asked about investigation without black boxes. Yes, it's very possible. We do them all the time. The black boxes, by law and by ICAO standards, which we domesticated to ourselves, are only in certain aircraft of a certain weight category. For the smaller planes, these ones that crash all the time, they don't have black boxes. They don't. I think the weight goes up to 5 tons, if I'm not wrong. You're not required to, 5,000 pounds. You're not supposed to have a voice recorder or a cockpit voice recorder. If you have it, it's to the advantage, yeah, but it's not a must. So we do them all the time, and yes, it's possible to have investigations without recorders. They just play a bigger role. But again, what helps us is that most of these crashes that happen of the smaller, there's a reason why they put a certain weight limit, because there's a percentage of the smaller planes that are very survivable due to the low speeds, the low weight. Most of these students pilot walk out of their training aircraft after crashing, which is good. And again, aviation is all about safety, but again, it's all about making money. If you're not making money, there won't be aviation. So these small aircraft, once you start adding weight, like voice recorders, it will not make sense. But yes, we do carry out investigations, mostly eyewitness accounts, analytics skills that we are taught in school once you find the wreckage. So the voice recorders help when, like the Mwihoko one, where evidence has been looted, or when it has fallen into the sea, there is no much evidence, or it has crashed so bad that you can't find any evidence left. Voice recorders helped in that, but yes, we can carry out without black boxes. Which technology do I wish could make our work easier? I'm assuming by our work you mean aircraft accident investigation? Yes. For sure, we'd love to have AI. We'd love to have all the aircrafts to have voice recorders if they can make them small enough. The reason why a voice recorder is so bulky, by the way, is because of all the protection it needs. Otherwise, a voice recorder can be just one memory stick, but it's protected by all that. So if there's a technology to make that easier, and maybe hopefully one day there'll be incorporation of videos into the flight deck. I know Airbus helicopters have started, but most aircraft don't put videos into the cockpit because the Pilots Association have been very much against it. Goes against privacy, goes against everything. But you see, with the Air India flight, would have actually known who put down the switches, or if they went down by themselves. So those are some of the things I wish. About Concorde, Concorde on its own, as the name, it will never fly again. It's gone. It's a relic. It's dirty. It's uneconomical. It just doesn't have modern solutions. Sadly, we are nostalgic, some people like me, but it will not come again. But supersonic flight looks like it's coming back. There are really good companies like Boom Aviation that have managed to cut the shock waves, that the boom is not that loud. I can't get into specifics of that, but hopefully, yes, it will come back. It will come back. Babesh, yes, got the name. The biggest contributor to, as I said, to aircraft accidents still is liveware, is human factors. Because the human factors is hard to evade. It's not only pilots, it's air traffic control. It's not only air traffic control, it's maintenance, engineers, technicians, the people closing the door, the people loading the aircraft. The human factor is all over to a point that it has to be the biggest contributor. because it's in every aspect. Even the machines themselves are designed by humans, so that can lead to human factors. Operations, why do you let your pilot not rest? Human factors. Human factors is the biggest by far, 70%. I'd say 75 even. Hope I've answered your question. Mark, your question on, what was your question on AI? Sorry? I know it was about AI. I just, I've tried to cram them.
Hi, once again. I wanted to know how engineers are using
Oh, yes.
are planning to use AI in their safety measures in making aircraft safer.
That question is broad, but I can try and answer it. There are different levels of engineers. The ones who design, those ones might be the one in need of AI more than anyone else. Because the ones who design and manufacture can use the AI to predict possible stresses, possible scenarios that humans could never calculate. What if you can feed a machine? What if this is the situation? What if the temperature dropped with this? How will it be affected? As for the post manufacture, it's hard to say. The maintenance ones might need AI, maybe to make their tasks easier. Maybe there are tasks that come from manufacturers that take way longer time. If you put them in AI, they can tell you an easier way to do it. That's what I can come up with from the top of my head. For us engineers of aircraft accident, it's gonna be a bit tough. I don't know if we'll need AI because we go after the fact has happened. Maybe AI to help us do simulations, but so far I don't see where we interact with AI, but it's a good question and I'll definitely sleep over on it. Lastly, Susan, let me start with Wilson. Wilson, I'm not the right person to talk about it. Sadly, coming at the tail end after whatever would have happened. This mainly lies with Kenya Airports Authority and Civil Aviation Authority, and in conjunction with the government, NEMA, the people constructing high rises, because the construction is still ongoing. Concerns have been brought up, yes, and we are already seeing the effects. There is an incident, a media collision that happened, I think it's last year or the other year, where two aircrafts collided above Wilson. Of course, errors are here and there, but one of the main factors is because the aircraft that are supposed to go up to Bellevue end up turning way before, because they can't climb, the small aircraft can't climb high enough to clear the buildings to go up to Bellevue and then do a full circuit turn. And so they do a truncated turn, yeah, because of the, and this one was given clearance to take off, not knowing this guy had done a truncated turn, and then they met. So it is a main area of concern, but I'm not the right person to address it, but I do acknowledge that there is an issue there. I hope the right people will pick it up and do something necessary. Skills required to become, I'm not sure which one you are asking, to become what, an accident investigator? Or to... Oh, yes.
That's part of the skills in your team, and what other skills people have in your team in your career?
There are many skills required, to be quite honest. There are some that are not taught, like diligence, curiosity. Such things are never taught, but when you go to the teachable skills, You need to have good analytical skills. Yeah, such things. Basically, it's all about being diligent, capturing what's supposed to be captured and properly analyzing it to come up with the proper solution. The last one was something about time consuming. What was it? The most tedious step for us, and the most tedious step by far, is evidence collection. Because that's the last point. Because it's not only about going to the site. After taking the black boxes, you have to go and analyze them. You have to go and talk to the pilots if they're there. You have to go and talk to the maintenance people. You have to go and talk to the company. You have to go and talk to the families and find out what the pilot was like. We have to coordinate with the NTSB, with the Cessna, with the Rolls-Royce. So it ends up taking almost 6 months of your time. That's the hardest part, or the time that's the one that's most consuming. Thank you for indulging me. If there's nothing else, I request to hand over. Thank you.
Thank you for joining us today. I think you may be coming from different parts of the world, so welcome. Oh, nice one. Thank you. Is it working? Okay, it's probably not working. I'll just do that and we can just change the slides. It's a PDF, not a PowerPoint, so that might be the reason. Anywho, because Sabrina yesterday and probably Igal already gave you a speech about why AESS is so important that you should be a member, and because this is the big sponsor, I'll probably spare you another speech about that. So they've been sponsoring me coming here to talk with you. So I'd like to present radar sensing in the context of assisted living, and you'll see how this relates to autonomous systems as well. Okay? Next slide, please. So in Japan, China, the US, Europe, we have a very rapidly aging population, but that's why. A rapidly aging population, that means, sorry, the ringing is distracting. So that means that we may not have enough workforce for, okay. I'll just speak louder. Can you all hear me? Smashing. Okay. So essentially, we might not have enough workforce to actually look after every elderly person in their homes. And people like to live in the comfort of their own home. Okay? So as we live longer, you know, the lifespan does not necessarily match the health span, the time that you're staying healthy at home. So we need to find new ways to monitor people in their own home. Thank you. To monitor people in their own home so that we can keep them safe and their carers or their children, brothers, sisters can actually be confident that their loved ones stay safe. Okay? Next slide, please. So, assisted living in our context looks at activities of daily living. So, bathing, eating, toileting, transferring, dressing up, and walking. And those are the minimum activities you're supposed to do at home on your own to survive. Okay? I didn't say live, I said survive. Okay? You have an extended list for living, but this is the bare minimum. Okay? And then you can look at vital signs, monitoring, breathing, heart rate, blood pressure, etc. And from those two sets of information, activity and vital signs, you can start being very precise in predicting healthcare outcomes. Okay? Next slide, please. So assistive technologies are not new. There are some very known ones. A lot of you have one in your pocket. Okay? Your mobile phone is essentially a wearable. It can actually collect information from you as long as you wear it. Okay? But in those circumstances, a lot of accidents, falls for elderly people, happen at night where you don't have your Fitbit or your pendant or your phone on you. Okay? So wearables are actually quite good as long as you wear them, but they can be quite limiting. Cameras in the home space, you can imagine why. I'll just speak louder, don't worry. So cameras in the home space, you can imagine why this can be a problem. How many of you would like to have a camera in your bathroom or your bedroom? And if you say no, that's the same for 99.9% of people. It's very invasive of privacy. Okay? You also have other ambient sensors like infrared sensors that are used to detect presence in the room. So this is quite well accepted, but the information you get from that is quite coarse. You only know if a person is here or not. Okay? You also have microphones, and I'm pretty sure that even though you may have an Alexa in your home that already listens to your every conversation, you might not know that, but they do. Microphones are still a bit invasive of privacy. Okay? And smart floors, also quite good. However, the price of refitting your apartment defies the purpose of having them. Okay? Because if you have to pay as much for your sensors as you do your apartment, this is sort of not really equitable for everyone else. Next slide, please. So that's why when you're devising a solution for a target population, it's very important that this solution is designed for them in mind, okay? Because your tech can be absolutely brilliant. Oh, I have this very fine-grained camera, best picture in the world, clear, it can see in the dark and everything. Brilliant. But your end user will never buy it. So take that into account when you're developing technology, that you need to work and design it with your end user in mind, okay? And that's why I like this graph, because it looks at perceived privacy versus the level of information you get from that sensor. And you see visible camera at one end, okay? Rich information, but privacy, no, okay? And on the other end, you have infrared sensors. Hey, I like that, but the information you get is not so good. And I like to put radar up there because how many of you have radar at home? Oh, sorry, Wi-Fi at home. Everyone. Good, you already accepted the technology in your own house. So, as Sia this morning was mentioning, 6G will be integrating communication and sensing in the same front end. So very soon, deployment won't even be an issue because it will be deployed as part of 6G access points, okay? So right now it's not there yet, so we still work directly with radar front ends, but this is coming, okay? Next slide, please. So why do we choose radar to do, oh, sorry, you went a bit too fast. One slide up, yep, thank you, no. There, that's it. So I don't know why they're slightly shifted down, but that's okay. So the advantage of radar in this situation is that you don't need to rely on the acceptance or the compliance of the user, because just like Wi-Fi, you put the box there, they don't need to touch it, okay? And it's extremely useful, especially when you have people who have cognitive decline, like dementia, Alzheimer's, Parkinson's, where the cognitive abilities might be challenged. So they don't need to remember to do something with it, okay? Sorry, I'm not finished. So you don't need to wear a device. We will see in a minute what a radar signature looks like, and you will see it's very private, okay? And you don't need to remodel your entire environment. And if you're scared of stigma for having such a device, you can always hide it behind a radome that you can decorate to look like a painting or something decorative, okay? Next slide, please. So I'm going to go through the process of how we generate microdoppler signatures, okay, from a radar system, and how we use this to classify activities based on those signatures, okay? So we usually go from the radar system itself, or we simulate it, okay? We can use synthetic data as well to train our models. And then we will go through the signal processing chain. This usually involves quite a lot of time frequency transforms, okay? Like short-term Fourier transforms. Have you heard of Fourier transform before? Yes, you have. Fantastic. I always want to double check if the room knows or not, because I can explain it, but if you already know, fantastic. So we'll look at two examples of that in a minute. And then once we have the signature, and you see the signature there of a person walking, and you can see, do you recognize me from that? It looks like me, right? No. So it's very private, yeah? If you steal my data and you see this, oh yeah, that's Julian. Yeah. Who's that? And that's the whole point. If you hack my network and you get that data, unless you have expert knowledge on how to recognize that this is me, this is nearly impossible to actually recover that data, yeah? So it's very good for cybersecurity as well, okay? So once you have the signature, you can extract some information from that to try and classify those activities, okay? And I'll go through that with you. Next slide, please. So most radar systems nowadays use FMCW waveforms. So I don't know if Egal walked you through that yesterday. He did not? He did. Oh, so you know all this, I don't need to explain it. I'm joking, don't worry. So it's a sweep in bandwidths from a low frequency to a higher frequency, okay? And then you repeat that cycle several times continuously so you can have updates of what's happening in front of the radar, okay? You transmit this, and as you can see from the time domain on your right-hand side, this looks like a sine waves that accelerate, okay? It hits a target, comes back, and that's where you can see that dotted line in the top left corner. And this is the return signal. And you can see from that you have a constant frequency difference between the two sweeps, yeah? So when you mix those two signals together, what you obtain is a constant frequency, okay? And we're going to see how we can use this to actually detect the range, because radar works with time of flight to detect the distance of its targets, yeah? Next slide, please. So the frequency difference, because that difference changes with the time delay, is directly proportional to our frequency offset. So if we have three different targets, as you can see over here, So bottom, sorry, I'm going to get there. No, bottom left. It's on my right, but your left, so I need to, sorry. So if you have 3 targets at different distances, you will get 3 different offsets and frequencies, okay? Because the time of flight to go to those targets will be different, okay? So we mix that with our transmitted signal. We apply a low-pass filter because when they are mismatched, then you have a very high frequency difference, okay? And then I obtain 3 beat frequencies for return 1, 2, and 3, okay? So if you know the magic of Fourier transforms, we go from time domain to frequency domain, okay? So in time domain, that looks like a very noisy signal, yeah? It's jumbled up together. So we digitize that with an analog to digital converter, and then we apply a fast Fourier transform to extract the frequencies from that signal, okay? And then we get the distance for target 1, 2, and 3. And yes, you're seeing frequency, but I just mentioned that the frequency offset is directly proportional to the time delay, right? So with a simple rule of 3, you get back your distance, okay? And that's what, honestly, 99% of radar systems at the moment use, okay? Next slide, please. Now, with 6G, and you also have other systems that use different waveforms, you need to have a way to recover your time delay for your targets more generally. So here's an example of what you need to do for an OFDM waveform, for example, okay? So you would need to actually digitize the entire bandwidth of your signal. So you can no longer use the trick of demodulating it with the transmitted signal. Because here you have a comb of frequencies being transmitted at the same time. So if you mix them together, you will have a frequency fest at the end of your mixer. And then this will be unrecognizable, okay? So we use a super heterodyne architecture, and we use a single local oscillator with 1 sine wave to bring the signal up in frequency to transmit it, and the same one to bring it down to intermediate frequency so that the ADCs, the analog to digital converters, can actually digitize the bandwidths. Because the higher the sampling frequency of your ADC, the more money it costs, okay? That's why we bring it down in frequency, okay? So once you have digitized your signal, you can either have a reference that will help you compensate from some of the hardware defects, or you can use a digital replica of what you have transmitted. Okay? Next slide, please. And you see that's where, when you have the entire bandwidth of your signal, things get a bit more complex in terms of how you recover your distances. Okay? So in short, what you need to do to make things simpler, so you take one period of your signal from your reference and 3 periods of your signal from your received signal, okay? You zero pad it to 4 times that, okay? And then you go to the next power of 2. And why do we need the next power of 2, you think? FFT calculations are optimized for power of 2 calculations, okay? If you don't do a power of 2, you need 3 operations with order 2 FFTs to get the same result, okay? So it's about the speed of processing. All right? After you have those two, what you do is a simple FFT to get into the frequency domain, because normally you need to do a correlation of the two signals together to obtain the range compression to detect your targets. The beauty in the frequency domain is you can do that operation by simply multiplying the signals point by point in the frequency domain, apply an inversed FFT to recover the time domain, and you have your range compressed. Okay? So this is my range detected here. Next slide, please. So once you have your range, this is what happens for one pulse. Okay? Now, I need to know what happens as a function of time. So I repeat those pulses, and I collect those range compressions, so the different distances of the targets in front of the radar in a row. Okay? But now I'm interested to see if there's movement in that scene. Okay? So now I want you to imagine a second sampling mechanism. Okay? Just like the ADC samples the signals very quickly, yeah? This ADC, which is the frame for every range compression, samples the Doppler phenomenon, okay? The change of speed in the scene, okay? So if you're observing someone moving, if you look at the range they are at, by the difference in range, I could actually infer speed, right? So you have a second sampling frequency, which is your pulse repetition period, okay? And this is very important for aliasing. So considering the speed of the targets is very important to avoid, getting the wrong answer, essentially, the wrong speeds. So after collecting enough range frames, you can apply an FFT to actually look at the modulation of the phase within my range compression to get the Doppler. And you have a representation that is called Doppler range profiles. Okay? And this is very important. Next slide, please. So the process here, as you can see, we go from the raw data. We get one range compression, yes? We collect them as a function of time. We use a short window, okay? We apply an FFT on that window, and we obtain a range Doppler image, okay? If we sum the ranges together, we just have one Doppler slice, yeah? That we can put as a first slice for my spectrogram or micro Doppler signature, okay? And then in the range time, I shift my window 5%, and I repeat that process until I reach the end of it. So that means I will get a new range Doppler profile every time, and a new slice for my signature here. Okay? Is that clear? You can interrupt me if you have questions, okay? And this is the basis of what we do to extract information to try and recognize those signatures in the home. Okay? Next slide, please. So, microdoppler signatures: sit, stand, bend to pick up an object, tying shoelaces, a frontal fall, and checking under a bed. And you can see that they look alike quite a bit, yeah? Especially a frontal fall versus tying a shoelace. You don't want to confuse the two, because in one case, call an ambulance. In the second case, you're just tying your shoelace. You don't want an ambulance showing at your door, yeah? Next slide, please. So in terms of interpretability, So this is a person walking, me. So as I'm walking towards the radar, I have positive frequencies, positive Doppler. I'm getting towards the radar. And when they're negative, I'm going away from the radar, okay? The big red stripe in the middle is my torso. This is the biggest effective area on my body. This is the most reflective, okay? And the modulations around that is actually my arms and legs, because my torso moves at a certain speed, but to do that, my leg has to go 3 times that speed when I'm walking so that I can maintain that speed, yeah? So that's why you have modulations around that, because my arms are thrown back and forth. So you have modulations around my torso indicating a different activity. So this is walking, and I showed you the others already. Next slide, please. So here we're using very specific techniques. I told you about STFT, okay? This is what's used the most because it's very efficient to calculate, okay? There are also super resolution techniques to try and get a much finer grain of information, okay? They're called, well, one of them solutions is called an iterative adaptive approach, okay? And this is used to refine the Doppler resolution of my signature. So you see the difference between the two here. And what you have to keep in mind is to stay within real-time performance, because it needs to happen on a resource-constrained platform. Okay? Next slide, please. That's odd. Next slide again? Yeah. Okay. So, I must have copied the slides and everything. So I've just presented you this here, okay? However, radar has many more data representation domains, okay? You have cadence velocity diagram that helps you determine whether there is repetition in your spectrogram, in your microdoppler signature. You can get composite views of the range Doppler with 3D data cubes with range Doppler time surfaces. Or you can try and integrate them together to try and see if that helps you recognize other activities. You have cepstrograms when you're digitizing the entire bandwidth. That helps you see if there are modulations within that bandwidth before you do any range compression, etc., that could be indicative of target characteristics. This is used, for example, to detect repetitive motions like rotors in helicopters or UAVs or walking, okay? And then you also have less common techniques, cyclostationarity, which is used usually in telecommunication to recognize which modulation is being used, if it's QPSK or QAM modulation, for example. But moving in front of a radar is modulating the signal. So we've used it as well to try and recognize activities from that statistical moment being used for that detection. And radon transform is actually coming from medical imaging, and it's using, instead of doing an STFT on the range time representation, you do a radon transform to try and reconstruct a specific surface that could be quite characteristic of an activity. Next slide, please. That's strange. Can you come back one? No. Okay, just leave it like that. Must be missing a slide. That happens. So this representation here is for one channel. Okay? Most radar systems nowadays are multi-inputs, multi-outputs. Okay? So you can get angular resolution on top of that, and as many of those as you have channels. okay? So you can see at the outputs of each of those representations, you have different AI algorithms being used to try and extract data automatically and try to recognize that those activities more effectively. So here I'm just opening a can of worms. I'm not saying I have the ultimate answers. This is why it's an active area of research. Okay? Next slide, please. So crudely, once we have those representations, what we do is we extract features. We can do this manually with energy features, physical features, image-based, periodical, as you define them, okay? And when you're dealing with data, I would invite you to actually do that initially, even if you're going to do deep learning, okay? Because you need to get to know your data. You need to look at it, feel it, get some understanding of what it is you're working with, okay? Because if you do that, you will design better AI algorithms, okay? Domain knowledge is very important. And what we're trying to do, and I've represented here a three-dimensional space because that, I'm a bit limited to that myself with X, Y, Z. Maybe time, but at one instant in time, just 3 dimensions. But if you have n features, you have an n-dimensional space, okay? And by looking at projections, you're trying to see if you can separate clusters of activities from one another, okay? Next slide, please. So in the early days of machine learning, we were using support vector machines. So this is trying to define a boundary in that n-dimensional space to separate the different classes from one another, okay? K and N is a very easy one to understand because it's looking at the unknown sample, and if you have 3 other samples next to it, in this case 2 circles and 1 blue square, okay? It will decide the new sample is actually a red circle, because the majority of samples next to it are red circles. If I extend that to 5, the answer will change, okay? So it's trying to determine which family the new sample belongs to based on voting, okay? And this is always an odd number to avoid a deadlock, okay? Next slide, please. You also have random forests trying to make different decisions and using all of the trees to vote or make an average at the end to come up to a prediction. Or you can use deep learning, and the most common one is to use vision, because we're very good at knowing what we see with our eyes, yes? We can understand it better. Not necessarily the best way of doing it, but this is what is most common the first time you go into a new area over there. Next slide, please. So what we do to train our models is we actually have to create a database. We train our model to try and recognize those features, and then we present a new sample, okay? And what you see here is called a confusion matrix. Everything in the diagonal, brilliant, it works, okay? Everything else on the side is mistakes my algorithm has done in recognizing the activities. So you have true class on the vertical axis and predicted class on the horizontal axis. So you see the predictions, if they're not on the diagonal, as a mistake. And this is where the gold is. Why did it get it wrong? Okay? When you have a sample that's misclassified, you need to investigate why did it get it wrong to try and refine your model. Okay? Next slide, please. Next. This is what I wanted to show. Okay. I might have forgotten to delete some slides. Sorry, next slide. I talked about that. Thank you. How much time do I have left? Because I must be nearing the time, maybe 5 minutes. I know my slides, so I know how much time I take. So you have a few challenges with radar, because I mentioned radial direction when you go towards the radar, when you move away from the radar. What happens if you're sideways or completely orthogonal to the line of sight? This is what happens to your Doppler signature. So you also need to incorporate real-life scenarios to your implementations. Okay? Next slide, please. So here we tested different geometries of radar to try and see if we could recognize activities robustly independent of the angle the target was presented itself. Okay? Next slide, please. So one thing we added is as you move away from the line of sight, you have seen that the Doppler signature decreases, yeah? And using an interferometric channel where you can take two receivers distant from each other, correlate the two entries together and integrate it, you recover the angular frequency of your target. And you can see now that at the line of sight, it's actually not doing very well. But as it moves away to orthogonal, I'm recovering that information, yeah? Next slide, please. And that interferometric implementation using micro-Doppler signatures plus interferometric meant that from 0 to 90 degrees, we could maintain 97% accuracy for our recognition, okay? Whereas the other systems were actually slowly going down, okay? Next slide, please. So another difficulty in this field is that actions don't happen, I'm walking, stop. I'm sitting, stop. Things happen in a continuum, okay? So segmenting that data is also an open topic of research, okay? And radar in assisted living, it will be one sensor within other sensors that will need to recognize activities in unison with sensors that work at different frequencies and have different data, okay? So your AI models need to work at different speeds. Next slide, please. So how do you do that? You need to work not with GPUs, but FPGAs, okay? So field programmable gate arrays will allow you to work with different speeds in your sensors, okay? Because the circuits you design in an FPGA can work at different speeds, okay? And then you can integrate all of that into neural networks that are also implemented on FPGAs. Because as I said, we need to be resource constrained. Whether you're doing that in someone's home or a UAV, you're not going to carry your GPU servers with you on a drone, yeah? Correct? You don't see them carrying a whole bay of servers, yeah? So it's resource constrained. It's important that you move away from GPUs to more efficient implementations. Next slide, please. Okay. So what I like to prone usually, and I'm coming back to this again, is domain knowledge is very important. Because what we have shown with this publication here is that if you're a bit smarter with your signal processing, you can do with a simple support vector machine what vision-based deep learning algorithms can do and better. Okay? So it's a lighter implementation, it's a cheaper product, okay? So it's more accessible for the people who will be using it, okay? And because I'm running out of time, if you can jump to the second last slide, please. Keep going, keep going. Yes, thank you. And up until now, I was saying that the radar was fixed and the target was moving, yeah? In aerospace or in the home, the radar is moving and the target is moving. So you also need to find ways to compensate for the platform motion, okay? And the platform motion can be simply because your radar is mounted inside your TV or inside an air conditioning unit or a UAV or an airplane, it doesn't matter, okay? The vibrations, the change of trajectories, everything needs to be taken into account to try and recognize what's happening in front of it, okay? So here, this is actually an ego motion compensation platform, sorry, a signal processing chain, to try and use fixed targets, okay, as anchors to determine the position of the robot in the room, okay, as it's moving. And we filter out moving targets from one frame to the other to distinguish between the anchors and what's changing from one frame to the next, okay? And from that, we're able to compensate. You see at the very bottom, a deformed spectrogram, because the platform was moving at the same time as the subject was moving. And at the end is the signature compensated signature. And you've trained your algorithms on that, so it can recognize this, okay? And I will conclude this on that. Thank you very much, and I think I'm on time. Bang on time.
It's strange being the speaker right before lunch. So I know many of us already, Pavlov's conditioning is taking over. And a lot of you are just waiting for lunch, so I won't keep you here for long. Mine is simple. Mine is specifically actually a call of action, a call to action rather. But before which, just a quick introduction. My name is Kelvin Nyabuti. I'm a remote sensing analyst with the United Nations. I work for Food and Agriculture Organization of the United Nations. I work for the headquarters, Digital FAO. The specific division is Digital FAO. And, oh, right, thanks. Yeah, so the specific division I work with is Digital FAO and Agroinformatics, where we try as much as is humanly possible to use remote sensing technology to help solve world hunger. I'm an alumnus of the University of Nairobi, where I studied geospatial engineering, and currently I am doing my master's at the University of York in computer science, machine learning, and artificial intelligence. So that's me. All right, I don't want to bore you with too many details. I know many of you are in the aerospace sector, not in the remote sensing sector, and so I didn't want to bore you with too many details about what remote sensing is and whatnot, but my idea here today is specifically a call to action. Because my work as a remote sensing analyst, my work as a geographic information systems expert, and my work as a geospatial engineer is built upon the foundation of what you guys do. Because my specific area of expertise is the application of satellite imagery for early warning systems and environmental monitoring, and also the application of global navigation satellite systems. So that in that particular sense, then you understand that I can only become as efficient as someone who is actually designing, monitoring, and evaluating satellites is. So my idea, what I was asked to present on is the idea of remote sensing. But what I actually thought to speak about is what I believe should inform the design, or rather basically research and design of satellite systems that would help actual remote sensing experts like myself solve what we believe are today's pertinent problems. Because guys, this is the point I'm trying to make. Ultimately, engineers, aerospace technologists and whatever exist in some sort of cloister where we usually, people are usually up about the latest reforms, or rather the latest innovations. And more often than not, it begins to feel like it's innovation for innovation's sake. It begins to feel like it's just a race to see who will be able to come up with the next best technology. But from where we stand, where we deal with more people-facing tasks, you realize that ultimately, the end of all of it is simple. It's all about people. In my specific area of expertise, we deal with problems that specifically face actual real farmers. So for example, one of the projects I am in charge of right now is building an early warning system for a zoonotic disease called Rift Valley fever. Anyone here who's ever heard of Rift Valley fever? Anyone? Right, Rift Valley fever is a zoonotic disease. By zoonotic, I mean it affects animals, and specifically cattle. And it's a disease that's prevalent within East Africa, but it also spreads all over Africa and Saudi Arabia and Yemen. In 2020, through the systems that were built, the rudimentary systems that were built in FAO that we currently are now developing to enhance, there was, it was predicted that in 2 months, somewhere around April, there would be an outbreak of Rift Valley fever. Now, many of us might not actually know that, because as a result of the predictive systems that were built by the Food and Agriculture Organization of the United Nations, we were able to curb it before it actually spreads. Now, this might not concern you too much, but for the farmer who's actually in the field, for the person who's owning the cattle, for the person who is there rearing the sheep and the goats and whatever, it is actually completely important because it affects their livelihood. And the reason why I'm starting with this is because we're getting to the place where, because of the kind of development that is going on in the tech world, people are now getting into innovation for the sake of innovation. My clarion call today is that it must first begin from the real problems that keep people up awake to now offering solutions that result in the betterment of the livelihoods of people. You see, I was speaking to a friend of mine, and the discussion we were having was that I don't know any farmer. For example, now I'll use farmers a lot. Again, you understand my bias because I work with food and agriculture. I don't know any farmer who sits up at night, wakes up in the middle of the night at 3 a.m. and is plagued by the questions of, how can we increase the resolution of hyperspectral sensors? If any of you know any farmer like that, please refer them to me. I'd love to have a conversation. But the questions that plague people that we work with are questions such as, will my crops yield? Is there any way I can estimate the yield of the work that I have done this season to make sure that my efforts are not in vain? The questions that plague farmers, and many of you, maybe some of you here, come from farming backgrounds, and you might have gotten into tech. My biggest problem is that we're getting to the space where, as engineers, we are entering some sort of cloister where it is a competition to show that I am the one who will come up with the next best innovation, and we end up producing so much, doing so much research, publishing so many papers that do not have any real-life applications, or rather, that don't leave the desks and get to the place where they actually influence the lives of real people. In my experience, I have had the privilege as part of the team within the digital FAO of going to different countries within Africa to go and train people on how to use the systems that we build. And one of the first things that struck me is that in every single instance, something that was outright in every single place. A few months ago, we were in Tanzania launching the Rift Valley fever platform that we have developed, built on sophisticated models, built on satellite imagery that is obtained from satellites that have been so beautifully designed by aerospace engineers. But the first question that one of the farmers asked was this: I did not study to understand all this. How am I supposed to take this and apply it to my farm where my animals are dying because of Rift Valley fever? So that then we sat down as a team and decided that from henceforth, every single thing that we will be trying to do is this. The people we are trying to solve problems for might not be as educated as us, so that then our aim is to take complex equations, complex models, complex processes, and break them down to such an extent that a local farmer will understand why they actually need technology to solve the problems that they are facing in their farm. Because ultimately, guys, think about it. If we don't get to the place where tech solves real-life problems, our actual real-life problems are food. And where we'll get our milk from, and our meat, and our diet, and whatnot. So that, yeah, we might be able to create the best hyperspectral sensors, we might be able to come up with amazing synthetic aperture radar sensors and whatnot, but if we don't get to the place where these things find application in real life, we won't solve real problems. And the reason why this is such an urgent call for me is because with the bird's eye view that I get being at the United Nations, people are suffering, and they are suffering in droves. Hundreds of thousands of people are dying, not because we do not have the latest aerospace innovation, but rather because every single piece of technology that we have that is actually perfectly calculated to solve real-life problems is not finding application on the ground. So that where is it? What is the place of engineers communicating these complex questions or other complex solutions that we've developed? What is the place of taking the high and mighty systems that we develop to the end user, who more often than not you will find is not someone who is as educated in the space sciences as you are? So that's my burden. My burden today, even if we don't go through all the slides, my burden today is to make sure that as you live here, you're living with this one persuasion. That yes, you want to become the next innovative creator. Yes, you want to become the next big name in aerospace. Yes, you want to become the person who will define this sector within the Kenyan space or the African space. Or maybe you believe that the world is your oyster and you want to define it in the world, fine. But my burden for all of us today is that as you live here, you live with this one desire. That I will not design for design's sake. I will not just do it for the sake of putting my name on the map, but ultimately to solve the real-life problems of the families we come from. So that let it be said that the people who left this conference left coming up with innovative solutions that actually tackled real-life problems that faced the end user. Now, just a little bit, you see, climate disasters, for example, have increased 83% over the last 20 years. 83%. Any of you who's even living in this country knows that this is true. When I was leaving my house in the morning, it was really cold, so I dressed up for it. I carried a scarf, I have a trench coat and whatnot. But then 10 minutes later, the sun was shining like nobody's business and I had to remove everything. You know, we experience in very microscopic ways the effects of climate. Now, I want you to imagine the person whose livelihood is actually derived from that. You see, many of you in this room are lucky because your livelihood is derived from using your brain. You sit down, you do complex calculations, you design, you think, you innovate, you create. But the reality is that is only a small substrata of the population. In fact, the highest echelon, if I may say so. But the reality is many of the people are the people who are actually affected by these climate disasters. And yes, to the women in the room, I will even say this. From the research that we have done, it is noted that there is a diametrical, that women are actually more affected by climate disasters than men. Because most of them you will find are the ones who are running households dependent on cattle, dependent on their farms, dependent on all these things. So that if there are diseases that are plaguing the farms, then you have people who are suffering as a direct result of that. 3.5 billion people on the planet right now are estimated to be highly vulnerable. And I highlighted specifically only the highly vulnerable. But within our organization, we categorize people into 5 different categories. So that almost every single person on earth, with the exception of only a small substrata, actually fall into mid all the way to very high vulnerability. So then why does this matter to aerospace? Because as a remote sensing analyst, for me to be able to come up with solutions to problems that are plaguing the farmer, for us to come up with early warning systems, for us to do proper crop stress monitoring, for us to do such stuff, we rely on the capacity of satellites to obtain imagery in a timely manner, to obtain imagery with high spatial resolution, with high radiometric resolution. You see, there are 4 things that matter to me. The images that I get, are they at the best spatial resolution that I can obtain? Are they at the, can I obtain the highest level of detail possible for the specific tasks I want to do? I care for the temporal resolution. Can I obtain the imagery at a timely manner? A few months ago, we were monitoring floods, and part of the task that we're doing, we're building some sort of early warning system that we call the situation room in FAO. And one of the things that we're very big on is monitoring floods. But you will agree with me that one of the biggest problems is that while we want to use satellite imagery to monitor floods, floods spread at a very high rate, right? So then what do we need? We need imagery that has a very high temporal resolution. So then we need to think about maybe coming up with CubeSats that are geostationary to ensure that we're obtaining imagery at near real-time resolution. Do you get the idea that I'm trying to say? so that we move from the problem back to the very solution. Not just, I want to create a CubeSat for the sake of creating a CubeSat. But rather because this is a flood-prone area, then can we commission a geostationary satellite that will continually be sending in images that we can update every so often, so to help us track the extent of the flood as fast as it is moving, so that we make sure that the interventions that we offer are such as will actually deal and tackle with the problem in situ at the time that it is actually occurring. So that's a burden of my presentation today. So I put in a few examples here of a few tasks that I am in charge of in my division, and the kind of imagery that we've been using. So things like vegetation stress, where we use NDVI, that is normalized difference vegetation indices, to try and analyze crop health and crop stress and stuff like that. Flood mapping, where we use synthetic aperture radar images to try and monitor the extent of floods and the rate at which they're spreading, to make sure that we have interventions for families that are being displaced by floods. LST, land surface temperature tasks, where there are people who are dying of heat strokes simply because of the temperatures that are prevalent in those areas, soil moisture, rainfall estimation. But once again, this might not be your burden because you might not be a remote sensing expert. But beyond all that, the idea that I wanted to leave in your minds is this: that for us to get to the place where we can actually solve real life problems, we need to have better platforms, better payloads, but I know there are considerations. There are trade-offs on orbits. You have low Earth orbits, geostationary orbits, you have mid-Earth orbits, you have all these things. And the idea is we need trade-offs between resolutions. So is there any way we can figure out the specific problems we are having and the specific satellites that we need, the kind of orbits they should have to ensure that the imagery is high resolution for the tasks that require high resolution imagery, or low resolution for the ones that actually don't, or continuous coverage for dynamic events like floods? I don't know about you guys, but I actually have a friend who lived in a flood-prone area. And he was an academic like myself. But the reality of the fact is that if you've ever been struck by disaster, at that particular point, it doesn't matter how smart you are. It doesn't matter your capacity to process information and to do all manner of calculations. All that matters is at that point, people are fighting for their lives. So that we who sit behind our computers to actually offer solutions, then what are we doing to ensure that these solutions are calculated and suited for the final user, the person who's actually being plagued by these problems? And that's the burden of our conversation today. So that yes, we have to consider payload constraints, power management, thermal control, antenna size limitations, sensor fusion, whether we can fuse together SAR and optical for comprehensive data, LiDAR and multispectral for enhanced analysis. And these are just a few ideas that I was thinking of when I thought of what an aerospace solution for the remote sensing issues that we go through will look like. Now, you are better placed to come up with such solutions, but as we finish this off, there are three things that, for example, in my work, have been a very big problem for me. We have partnered with some of the largest satellite imagery providers in the world in my organization. And as a remote sensing expert, once again, I need imagery as fast as possible, so that we have latency concerns. We have latency from data acquisition to processing. There are delays every so often. Very recently, again, as we were launching the Rift Valley Fever platform, we had an issue with the rainfall rasters that we were using simply because of latency issues on the part of the satellite imagery provider. So that as an aerospace engineer, is there any way we can come up with better solutions to ensure that such things do not occur when we are trying to actively monitor ongoing and dynamic events? There are, limited onboard storage capacity. Again, satellite imagery is very heavy. It must go through pre-processing. We must do all these things. Is there any way we can come up with better solutions to better manage such imagery? Data standardization and interoperability issues, where we have certain satellite imagery providers that have certain data formats and certain data pipelines that are not interoperable with others, so that while we are trying to get imagery, for example, from Planet and Sentinel at the same time, we have such issues that delay our capacity to actually solve the problems that we are trying to solve. So that here's the idea. we need to get to the place where we have aerospace-driven innovations, cutting-edge innovations that will redefine the scope and the precision of environmental monitoring. Now, I am not one to come and tell you how to do your job, in the sense that I am significantly aware that in the field of aerospace, you will be infinitely more learned than I am. But my plea is that as someone who, as a geospatial engineer, as someone who every day tries to use satellite imagery to solve real-life problems, can we get to the place where what motivates aerospace engineers, aerospace innovations, are actually the real problems that plague real people? So that a few instances of things that have been going on in the geospatial world that I am particularly excited about. One, ESA has onboarded artificial intelligence to help with pre-processing of images, to ensure that when images are obtained and downlinked to the processing stations, they are Earth observation ready. We usually call them EO ready imagery. So Earth observation ready imagery. So that once I obtain the imagery, because of the integration of artificial intelligence that has already done cloud filtering and reduced the data volume, I am ready to just pick it up and use it to solve actual problems. You know, Planets has come up with hyperspectral CubeSats, which have enhanced spectral resolution infinitely. One of the things, again, that I'm part of is a project where we are creating world boundaries, a unified data set. We usually call it GAUL, Global Administrative Unit Layer. And one of the things we are doing is creating a new coastline. Now, because of the hyperspectral CubeSats by Planet, we are able to actually map out the coastline to 5-meter resolution, to such an accuracy that was never before thought of. So such things are what I'm trying to talk about. You know, synthetic aperture radar miniaturization, so that we have high-resolution SAR data from compact satellite platforms to ensure that while we are monitoring floods and the extent, we can actually do so at a very high resolution, but also at a high temporal resolution, so that we're able to monitor them as they actually progress. And finally, constellation design for seasonality is another thing I thought of. The idea where, because we know, and as we monitor crops, actually crops work through seasons. The problem is that sometimes as we analyze certain seasonal data, we find that there are gaps because we're not obtaining imagery during those seasonal periods. So what if we come up with seasonal constellations designed for seasonality to make sure that that we are obtaining imagery during the seasons that we actually want to monitor? So finally, opportunities for collaboration. The aerospace community has a unique opportunity to contribute to global resilience through strategic partnership and actual innovative design. So that designing constellations, the things that I've mentioned, designing satellite constellations that are optimized for agricultural responses and disaster response, this will really, really help to solve the problems of the farmers that I have met. You know, developing low latency communication systems for data that is critical, data that affects the lives, the well-being of the farmers, of the end user that we are trying to solve problems for. Developing interoperability standards across sensor platforms to ensure that we can obtain data from whichever satellite provider when we need it, because ultimately it's all about people. It's not about whatever creative solutions we can come up. If they don't have real-life applications, if they don't actually solve real-life problems, then they'll be just another piece of good technology. So that's the idea, and that's it. I believe climate resilience is an expanding area for technological innovation and growth. And if aerospace engineers commit themselves to innovating for the sake of solving actual problems, then we'll be able to create systems that result in the well-being of our parents who are farmers, in the well-being of our relatives whose entire ecosystem is built around agricultural systems. We will be able to ensure that there is sustainable food production, and we will be able to ensure from the point of Food and Agriculture Organization that world hunger is a thing of the past. So that's it, guys. I don't want to say anything more because I know my time is spent and we are exhausted, but that's the idea. So if this is a conversation that you're interested in having, I've just put my email right at the very end. Feel free to reach out. I've put both my work and personal email. Please reach out. If it's for personal stuff, please reach out on my personal email. But the idea here is, if we collaborate, if we actually put together our efforts, we will be able to develop solutions that solve real-life problems. My encouragement to all of you today is this. It's amazing that you're an engineer. It's amazing that you're in the aerospace industry. It's amazing that you might be an electrical engineer and whatnot. But ultimately, if you don't offer up real solutions, then it won't matter. It'll just be another piece of technology for the sake of it. But the people who've left the greatest impact on this life, you will always remember are these people. The people who remembered that ultimately it is about people, about the care we show and the help we give. People need the kind of help that your creative minds can afford. My encouragement today to you is make sure any piece of technology you're trying to develop is aimed at solving real life problems.
Thank you so much. The first question, are there regulatory? So in aviation, basically everything you see in aviation, there is regulatory requirements to it, and everyone you see working in that sector is regulated. So when it comes to us, we have no exception. Yeah, we are also under regulation. So yeah, I'll give an example maybe of some of the regulations that we consider. We are guided. For example, how do I know? I need to know how heavy my aircraft is. But how do I know that? How am I heavy? So have you ever been, to an airport and then somebody asked you to step onto a weighing scale? Maybe, most likely not. But there is a way we determine your weight, and just so that we can all be on the same page, so that other people don't do things differently. There is a standard, and that standard is under regulation. So we all follow that to determine passenger weights and to determine, even that's why you find in a ticketing, there is always a certain amount of weight allowed. They'll tell you either 2 bags or 1 bag, depending on the aircraft size. So all that is part of the process that we use. So that's just one thing. There is many, but that's just one thing. Yeah. So we are regulated.
Yeah, and for the routes, apart from the fact that maybe the weather changes might occur, what else influences the routes that someone would take?
The routes. You've noticed that aircraft usually follow specific points in the sky. So yeah, there's like imaginary roads in the sky, and these ones have been designed by the regulator in Kenya. Now KCA in collaboration with the international regulator. So these routes, they are designed with certain considerations in mind. It's not about the weather. It's about, there are some, although nowadays it's not a must that you follow those rules because things are evolving. But if you go the traditional way, we'll say we have got like beacons that aircraft track and follow along the route. And so the aircraft can only be within a particular distance from that beacon. It's essentially like a transmitter. So the aircraft needs to be within a certain radius for it to be able to track the beacon. Because up there we can't see. Or let's say the pilots don't see. Okay, you can see, but you can't tell where you are. If you get lost, you can't really tell, I'm lost now here, but where am I? You wouldn't tell. Probably it's just clouds below you, it's just blue above you. You wouldn't really know where to begin. And that thing is moving really, really fast. 1 minute is a lot of distance. So to be sure, the routes are designed so that you're always within a particular distance from a particular beacon. So that's why you'll find that there are specific routes that aircraft always follow. Although that's the traditional setup. So now the weather changes, of course, can happen. Maybe there is a bad weather along your route. A good example is the case of a thunderstorm. Very bad business when it comes to aircraft operations. Typically, we will all want to avoid a thunderstorm. So if it is forecast, or if you see it along the route, you just take action by trying to bend your route such that you can go around it. But typically, when the aircraft goes around it, it will still be within a particular distance around that route. By the way, we request those routes. So you have to request so that you are given approval to fly that route. And there are charges to that. You are always charged at the end of the month for navigation fees. Yeah.
Both in the Kenyan space and internationally.
At least in Kenya, I'm sure. So, and I think the same case even international, because I don't think they will be doing anything different. Right? But nowadays you have GPS, which can route you anywhere to anywhere. So that's people are evolving towards that type of navigation. But still, the traditional routes are still in place, very much in place. Yeah.
Okay. And I'd like to know, now that you are on the ground and everything is done, and like you said, weather can change anytime. Is there an instance where you've had to change plans mid-air, and what does that look like? What's the protocol? Mayday?
No, not a mayday.
Okay.
A mayday is a call that the pilots make, usually telling them that they require immediate assistance.
Yeah.
Now, with weather, it's one of the major elements that we consider when planning a flight. One of the safety aspects we spend a lot of time. See that time where you're sitting down with a pilot. One of the things, in fact, you will not leave that discussion without considering how the weather is. And you look at the weather, not just along the way, you have to look at the weather even where you're going. Because if you can't see, let's say it's foggy where you're going, and you can't see, well, some places you can't land. Others you can land if you meet certain requirements. In other places you can't land, so it's a case of where are we going? There is a word we use, minimums. What's the worst weather that I can accept and still be able to land? And then now, what's actually there? And then you see, is what is there, is it what I can take? If it's less than what you can take, then we always have a plan B. We always have an alternate airport. So if we can't land there, usually that discussion will be there. So if we are unable to land here, where else do we go? And that other place, weather should be good. If weather is not good for there also, you will need another alternate, just in case we are unable to land even at the second alternate. So that's weather where we are going, weather destination, weather along the route. That will be factored in. We'll see how we can plan our route, go around the bad weather. But now you see when it comes to landing, it's more critical at landing, because you won't have that option of saying I'm going around. Yeah. So we usually consider weather at takeoff. In the cruise phase, when the aircraft is set up, we are up there. And also when it comes to landing, we look at all that, and then we consider our alternatives in all those scenarios.
How many plan Bs do you usually have at least?
And by the way, the law also, there is a way that the law has framed that planning. So how many plan Bs do I have? It depends.
Okay.
If weather is good where I'm going, just one plan B is okay. If there are two runways, let's say for example, and they don't touch each other, then the only thing that will prevent me from landing there is maybe another aircraft stuck on one of those runways. So if there is another one, I don't even need a plan B. If it's one runway, then the weather could be good, but an aircraft could get stuck on that runway. You will need a plan B. If weather is bad, you will need a plan B, where weather is good. If your plan B weather is also bad, you need a plan C.
Okay. Yeah. Thank you for that. And you have some sort of background in software. I went and checked your I'm lying. Okay, maybe I check someone else. But you could just tell us, what is the role of tech in this space? Like, what changes has tech made to make your work easier, to make in terms of data and automation? Because I'm imagining you use a lot of data, especially weather data, and like our weights to maybe create this thing. So what?
We didn't introduce each other. Well, there's one-sided information to us.
Okay.
Okay. On a right note, but
Yeah.
okay, some got some background in software. I mean, we're in the 21st century, so one way or another, we always interact with some tech here and there. And so, we won't mind to get our hands, you know. So, one of the things, let's say, so where I am, we have a fleet of about 11, it's what, 15 aircraft. And just Safari is very busy, actually right now, it's very busy. And with all these changes, right? Like let's say, there comes a time when your schedule is planned out, right? We need this aircraft to be here at this time and be off from that place to there at this time and so on. And you hope that the schedule will go that way. But there is always something that tries to knock the schedule off. And you know, when passengers are still arriving, you know, and they paid for these services, they want to be transported. You will not give them those excuses that, you know what, the schedule was like this, but things went south. So you always try to adapt and come up with new plans so that you can still be able to, you know, offer the services that you promised these passengers. So if you can have something that can help ease the burden, because there's a lot of consideration. I've just used weather, but there's a lot of considerations that you have to make before you even switch from one aircraft to another. You have to ask yourself, can that aircraft get the job done? Because if that was your plan A, if you're lucky that the plan B is up to the task as the plan A, then okay, but sometimes the plan B is not up to the task. So you will need something that can be able to, you know, get things done very quickly so that in case things change, you don't lag behind. So one of the things that you should have to compute is flight performance. It's a bit technical, but before you say move all those passengers here, or let's use this aircraft here, we need to know that first of all, is the aircraft up to the task? So you will need to do some numbers very quickly. And so, you know, I walked into Sparring the first day and, you know, it was okay, first month, second month, third month, something needs to be done, because every time there's a change, it's chaos. And so doing things the manual way, because there is no, or at least there was no way to actually be able to compute those numbers as quickly as possible. So, you know, I had read about something, so I just created a few things here and there to try and make the work easier. So if your question is, what is the role of software? Yeah, the role of software, for example, things like flight performance, personally, flight performance, temperatures go up and down, that affects the performance. You need a way to be able to calculate the new figures every time, every day. So it's not something that, you know, you do manually. You go to the manual, how the aircraft manual guides you to around this process. And it's charts, and you have to integrate charts and sometimes even do interpolations and extrapolations. It's tedious. So if there's a way to just have that information somewhere where you can just pull it off and compute it using the power of a computer, then that would be better. So flight performance for each different type of aircraft is different. So for each of those types of aircraft, also being able to do things like weather forecasting. We have got tools and we have got means of doing that, but sometimes to process the information, it's easier when you have got something that helps you, you know, form conclusions very quickly. So let's just say maybe out of my own, you know, effort, I've gone ahead and made a few things that make my work easier when it comes to that. And I think that's what you meant by have a background in. I will have a few things, yes, that I've computed to help my work easier. Yeah.
So, still on that, what do you think is what do you see as the future of aerodrome operations in the next 10 to 15 years? Assuming like a lot of things have been automated, yeah.
So the automation, 10 to 15 years from now.
Yeah, what do you see?
Okay, one thing, we deal with pilots, work with them. They love automation. They don't like doing things manually, even they fly. We had a pilot here yesterday. I'm sure, I don't think he's there today, no, he's flying today. They love automation, makes their work easier. Just want, just take off. We have something called the autopilot, if you've ever heard of it. Just tell the autopilot, now, take me to that altitude, keep me there, maintain this speed, maintain this direction, and just make my life easier. Let me just do the talking and just monitoring. So there has been limitations to that, but we are changing. Things are changing. Like I said, we are moving towards GPS navigation nowadays. 10 to 15 years from now, I'm seeing a world where, see these beacons I was telling you?
Yeah.
Those beacons have limitations of their own. That's why aircraft are fixed to, particular routes. 10 to 15 years from now, we're going to be doing more of GPS flying. We'll be retiring those beacons. And that will translate even to when it comes to doing what we call approaches. Because right now, there are some limitations. You have to design their systems, there are procedures that guide you into how you land an aircraft into an airport. Right now, those procedures are still guided more or less by the beacons. And the beacons, because they use radios, there are limitations. There are some places where you cannot build such procedures or such landing needs. If you have got hills around, then it's more like you have a transmitter that you can't receive from the other side. So with satellite navigation, signals come from above. That's what I'm seeing. 10, 15 years from now, that is what you're going to use. And that will enable landing or access to aerodromes that initially were not possible. And even if we can't see, if you can task the autopilot to do that, then see these disruptions you're talking about, weather and all that. Because if a place has got hills and then weather is slightly off, we are not touching that place. With an autopilot and with signals coming from above, it is possible to still fly an aircraft with sufficient accuracy that we might actually be there. So with technology, it will open access to different areas, some of which were not accessible before. And there is a discussion for whether or not we'll need a pilot. We will need pilots still, just to close that discussion. So technology will still be there.
Okay.
Yeah.
And then finally, for anyone here who might be wondering, how do you become a flight dispatcher? In a minute, just tell us, how do you become a flight dispatcher?
That is also regulated, like everything else. Yeah. So you go through an approved school, not just any school. Anyone who walks into a school and then the school claims to train flight dispatchers, ask for them to show you the approval, just so that people don't walk to any school and then they happen to not to throw away their money, because again they will need to go through an approved school. So walk into an approved school, you will need to get some training, and then the school at the end of the training will have to give you a certificate as proof that you are there. And the training can take some places 6 months, other places 9 months. There are places that take even a year. I would recommend, those which take a year. It's actually a course that there's a lot. And usually when you do it in 6 months, I find that you come off still needing some extra learning. I would recommend a year, where they take at least a year. You have time to process and digest information properly. And then after being given the certificate, that's not the end of the road. That's just proof to show that you have attended this training at a recognized institution. So the next step is you go to a regulator. For our case in Kenya is KCA. Depending on where you are, could be the FAA, could be the GCA for the Gulf nations, or the FA for the States, or EASA for Europe. It depends on where you are. For Kenya, we have KCA, so you go there. They will also give you sort of like an external assessment, an external examination. You claim you have gone through the system, let's see. So here is an exam for you, and then now you have to pass that exam. It's 8 subjects, and by the way, you go through the same training as pilots.
Oh.
Basically, word for word, everything, all the units is the same thing. So in that exam, you'll be sitting, the pilot, you'll be there, all of you most likely doing the same things. If you pass the exam now, they will issue you the license. Now, a license is like the authorization by KCA telling you that we now are confident in you that you can be entrusted with these duties. We found that you can manage yourself. So now once you have the license, then now you will now be qualified to get a job. And in the job, you also have to go through still regulation. You have to be taken through an on-job training. And after the on-job training, you will have to be released or checked out that now you are now okay to be let go. I mean to be released so that you can release flights unsupervised. Let's say that. Initially you're working under supervision, so now you can work unsupervised. Then now, at that moment now you are now a full dispatcher.
Okay.
So the process is not difficult, and the background where you're coming from does not matter so much. But I would say during the training, the learning, that's where most of during that 1 year, that's where you need to put in, everything that you have got, because that is what will define how you actually even maneuver out here. Because if you go to an employer and they interview you and it's competition, if you come off short, then you will always find yourself in interviews but not really breaking through. Yeah.
Thank you very much for sharing your insights with us. I think now we have a crash course on how to be a flight dispatcher. So thank you for your time. I think we'll welcome the MC to gift us.
From 15 different countries. That's amazing. So all of you, very warm welcome to Kenya. I know it's been cold most of the days by Kenyan standards. I'm told from the people from Glasgow that it's actually nice and fresh. They don't think of it as cold. But welcome to Kenya and welcome to Strathmore. I'm fascinated by the sorts of topics you people are discussing here today and these days. Engineering, aviation. I didn't even know there's a nexus between this topic and medicine, aviation and radar and medicine. I was just finding out over lunch. So just incredible, endless possibilities. Probably when we think of aviation, at some point, I guess most people wanted to be a pilot, at some point. All of us had like a crush on piloting. Like someday I'm just going to get hold of this machine and just fly it. It's always fascinated people from time immemorial. And when something like that exists, that's an opportunity for innovation. When something captures your imagination, it's fertile ground for innovation to happen. And so you can go as far back as you want in history when people just looked at birds and said, I wish I could do that. Like I wish I could just get from here to the top of that mountain and I don't have to do all the climbing. Or I wish I could just fly across this lake or across this river to the other side and I don't have to swim through it. There's got to be an easier way. And it actually spurred innovation. Some of the stories we hear, we're not quite sure how true they are, about people making wings and sticking them with wax and then realizing that wax melts. I don't think they were that stupid. But definitely people did try to make wings and fly like a bird. And then they came up with cars and said, can't we make this car fly? And when I'm in Nairobi traffic, sometimes I wish I could do that. Just 2 days ago, I was stuck in traffic and I started innovating in my mind. So I said, okay, maybe I can't make the car fly, but if I could make something shoot out from the undercarriage of the car, and then it basically pulls the car up in the air, and then I'm basically moving like on stilts, then I could just weave my way, because I was watching the motorbikes weaving in between the cars. And I said, I can do that if you just lift me and I'm on something that has wheels at the bottom, then I could just weave through this traffic jam, and when I reach a safe space ahead of all the cars, I just drop down and I keep going. So, and I was really thinking, I wish I could do that. And I know if I put my mind to it, if you put your minds to it, you could probably innovate and come up with something like that. Until everyone has it, and then now it's illegal because all cars are knocking each other in the air and on the ground. But the first time you do it, even the cops will be saying, what is that? What is going on? Because there's a car on top of all the cars weaving in between them. And by the time they're like, hey, stop, it's illegal. Like, which law? Where is it written? The law hasn't been invented yet. You're on your way. So you're in, fertile ground when we talk about aviation and engineering. So for those of you who are students, this is an excellent way to spend your time. In addition to all the stuff that you learn in class, I always say where you really learn to do things is out there in these kinds of activities. Why? Because you're so passionate about it. It's so interesting. And anytime something is interesting, you will spend time doing it. No one needs to persuade you or to force you to do it. And so all you just need to ask yourself is, what could I learn while engaging in this very interesting activity? And depending on what you choose to learn, you can be highly skilled. All kinds of skills: problem solving, design thinking, teamwork, persuading people to be part of a project, fundraising. All these are skills that you can use later on in employment. And you're not going to be taught this in class. You might be theoretically, but where you actually learn to do it is in clubs, in activities like this, when you're fully engaged, when your mind is fully engaged. And then I was asked by Joy and Ayushi to just speak a little bit about innovation, just to share some thoughts around innovation, because most of you are looking to innovate. I have a system called the innovation algorithm. So if you search for my name, Vincent Ogutu, and the innovation algorithm, you'll find a free explanation of how it works. But just giving you some high-level explanation of how it works. Very often we don't solve problems because we believe that we can't. Like only very, very intelligent people can solve such problems, or just people who are highly educated, or experts, people with years and years of experience. And when you look at yourself, you say, I'm not that, so who am I to even attempt to solve that problem? And so you give up. And if you give up, then your brain is not working at all. It's not taking up the challenge. You've basically told it, don't even try, you're out of your league, you can't do this. So your brain is off. So at some point you need to remove these limiting beliefs and just turn on your brain. Just convince it, of course you can solve it. Even conceptually, think about it like your younger brothers and sisters. There's no problem that they can't solve. If you think I'm kidding you, play this game with your younger brother or sister, or your nephew or niece. And I've done this so many times. So you just tell them, you can't get past me. And they say, sure I can. And then they move to your left. And then you step to your left to block them. Then they move to your right. Step to your right to block them. They try to come under your feet. And at some point, you've got to let them win. So you let them go under your feet. But if you insist on blocking them, then they climb over your shoulder and they roll over on the other side of the sofa, because they can generate solutions every second. Because in their world, there are no limitations. Another game I tell them is, oh, you can't shoot me. They say, yeah, I just did, bang, bang. And then I'll look, like, where did you shoot me? Your chest, die. And I'm like, I have a bulletproof vest under my shirt. Your bullet just bounced off my bulletproof vest. And they look at me and they say, bang, die. I'm like, why? So I shot you in the head. You definitely don't have a vest. I can see your head. There's no vest, so die. I say, gosh, you mean you can't see the invisible force field that I have, like right about here? Your bullet just hit the force field over here. And then I look at them triumphantly. Then they run up to me, jump in the air, shoot above, and now I have to be fair, so I die. Because they say, I went over the force field. I shot you from above. You're dead. And I accept. So what's the moral of the story? Whatever obstacle you give them, they generate a solution instantly. Why do they have that capability? It's because they don't have that limiting belief I'm talking about. In a make-believe world, they can invent anything on the spot. Imagine I was unfair and I refused to die, and I said my force field covers me, it's like an igloo. You think they'll be defeated? No, they'll just look at me, and then they'll just press something and say, there's a bomb under your feet, and it can blow up, in fact, the whole world. So who are you? You're just one guy sitting on a sofa with a bomb under your feet, so you're dead. And this time I have to die, because they just made it up. And for every obstacle I give them, they can generate a solution instantly. They have zero limiting beliefs. So the first thing you need to do is turn on your brain. Remove the limiting belief. Take on any challenge. Why do I say that? Because somebody somewhere is going to solve it. And then you'll be kicking yourself saying, was it that simple? I could have thought of that. Yes, you could have, but you didn't allow your brain to even start working because you had it off. You had these limiting beliefs. So remember, your brain is an incredibly powerful machine. Just turn it on. Second tip, you can turn on your brain, but it's crawling. It's moving very, very slowly. Or you can put it into a certain gear and now you're in turbo speed, so you're moving super fast. Your brain can do that, and you can trick your brain into switching to turbo. Now, if you think this is all voodoo, this VC is inventing stuff, there's nothing like that, my brain can't do turbo. Yes, it can. We've all been students here. You know how at the beginning of the semester you tell yourself, I'll be so responsible this time. In fact, I'll start studying for the exam on day one because I'm going to get an A in this exam. I even fancy myself getting 100%. The rate at which I'll study, there's nothing I can't answer. So I'm starting to study on day one. So you put the book in front, you try to read that first page of that first chapter and nothing enters. Then you reread that page, nothing. You read it 2, 3, 4, 5 times, it's not going in. Why? Because your brain is saying, why are we doing this? It says, because there's an exam. It says, but it's 13 weeks away. It's like, why are we doing this? So we're preparing for the exam. It's too far away. Like, I don't need to do this. I have other stuff to do, like keep your heart beating, lungs pumping. Like, this is a waste of time. You're like, do what I tell you. And your brain will say, no, I won't. And your brain will win that particular battle. Because there's no emergency. 2 weeks to the exam, suddenly your brain wakes up and now you can study. And then the example I love giving is 2 hours to the exam. This classmate, there's always a classmate like that, will come and tell you, have you read chapter 14? You're like, no, but we're going up to chapter 13, right? It's in the course curriculum. It says chapter 13. Did you attend Friday's class? No, I missed Friday's class. He told us that he's going to test chapter 14. Because he taught it, right? He taught it. And he said, I forgot to put it in the curriculum. Remember, I've taught it, so it's coming for the exam. So you better study chapter 14. Actually, if there's any chapter we know for sure is coming, it's chapter 14. Because why would he tell us and then not test it? So forget the first 13. This one is the only chapter we're sure is coming. 2 hours to the exam. You have classmates like that, right? Now, guess what? Your brain will magically switch to turbo. You'll grab that book. you will read chapter 14, you will understand it, you will master it, you will memorize it, and you will take an exam about it in 2 hours' time. Why? Because your brain has to do it. This is life and death. This is the only chapter that I'm sure of. It's a sure bet. This is the best investment I've ever done of my time because I'm sure I know what's coming in the exam. So your brain can actually switch to turbo and can think that fast if you incentivize it correctly. And then the third tip is, depending on which steps you follow when you're thinking, the work can be harder or it can be easier. If you try to invent the final product instantly, that's the hard way to do it. That's just really hard. Now you actually do need to be a genius and an expert and have lots of experience. But if you say everyone's trying to solve this problem in maybe 2 different ways, like 2 approaches, all I want to do is invent a new approach. So this is not about the final solution. It's just a new approach, a different way of doing things. Hypothetical. That's not hard. Your kid, brother, and sister can do it instantly. So can you. If all you're doing is inventing a pathway, not an actual solution on the pathway, just a pathway, hypothetically, there's no limit to your imagination. But the beauty of it is once you have a new pathway, getting an actual solution on it is really operationalizing an innovation you've just made. The outside-the-box thinking happens when you do things differently from everyone. And that doing things differently is basically creating a new pathway. It's so easy to create a pathway hypothetically. That's all you ever have to do. You create it and then you go and hire the experts. Like, have you guys ever thought of doing this thing? Instead of using these 2 approaches, you use this third approach. They're like, no. Do you have the technology to do it? Yes, we just never thought of doing it like that. Say, okay, so I pay you, it's my innovation, you work for me, done. So this is how you can think outside the box and innovate. Look up the article. It's called the innovation algorithm. So it's a 5-step, step by step. I promise you, by the time you reach step 4, you've innovated. You can solve complex problems. It should take you no more than 5 minutes to hypothetically solve a complex problem and invent a hypothetical pathway. I can do it in 1 minute because I do it so often. And your kid brothers and sisters can do it instantly because they've never been corrupted and told that you can't do things, you can't do this. They have no limits. So that's my gift to you guys. Keep enjoying these activities and participating in them. Set your learning objectives. What could I possibly learn from these amazing activities? Even just in this conference, 15 different countries, gosh, you could make so many friends. Next time you travel, you might not need to stay at a hotel somewhere. You have this amazing friend from another country. Life just changes. There's so many opportunities right here. And future jobs. Who will you impress in this room? You have so many interesting people coming in. So many possibilities, things you can learn, skills you can pick up, friends you can make. So please set yourself some nice, interesting objectives and go for it. So I wish I could spend the rest of the time with you. I love hanging out with innovators, but they just told me I need to be back in the office. So enjoy and welcome to Kenya and welcome to Strathmore.
All right. It is just such an honor to be here to speak to you, but also to follow, such an incredible speaker, the VC of this university. I know you guys you've been a bit serious, so I'd want you to stand up. Let's just do a small exercise so that we try and have a bit of energy. Cindy, let's shake off a bit of the seriousness. It's good to be serious, but let's easen up a bit. So I want us to do a small exercise. I've been given, I know I have to work with time, but just a simple one. All of you know how to spell coconut. Cindy, coconut, right? So make sure you have space. Make sure you have space. So I want us to spell coconut with our bodies. Sawa sawa. So we're going to do, so we start with C. So you start with C on your right. So C, and then O, and then C again on the other side, and then O, and then N, and then U, and then T. Okay, so then I'm going to do it very fast. Sawa. So then later on I'm going to mix the letters. So let's start. C, O, C, T, U, N, C, O, C, T. Good, good, good. Let's sit down. I hope you're now at least warmed up, fresh, feeling fresh. So my name is Charlene Chepkosgei. I am a geospatial engineer by profession, and I wear many hats. I don't know if I should speak to all of them, but how I'm also kind of related to, or basing on the topic for today, I mean, or the theme for this, it's on aviation and electronic systems. So I'm a drone pilot, I'm a licensed drone pilot, and that's where the aviation aspects come in, or how I'll be able to expound. So I did my bachelor's, just a small story about me. I did my bachelor's in Technical University of Kenya. I graduated in 2017, and then I did my master's in the University of Twente in the Netherlands. And during that time, I was privileged to work with NASA on a project, NASA Surveyor. So that's mostly using Earth observation data. So for me as a geospatial engineer, I'm not into the space, like working with satellites, but mostly using the space technologies to work into the different applications. And my interest is in food security, climate change, and all that. So during that time, I was privileged also to get into different programs. I was a mentee in the Space for Women, UNOSA Space for Women program that was running in 2023, and then I graduated from that. And that's actually one of the key pillars for me, because it really inspired me to start my own organization when I finished university. I'm going to talk about it, which is called Women in Space Kenya, where we do a lot of empowerment opportunities. So apart from that, I've been into different leadership courses. I've done change leaders at the university, and also I've been into different communities. So I'm very active, and I would definitely, of course, recommend everyone to be active in different communities. Like I've seen the IEEE in different universities. I've seen for Strathmore, I've seen for KU, for technical universities. So it's really good to be in such communities, because you get to learn so much. You get to collaborate with different people and all that. So then after all that, then that's when I came back to the country, and since then I've just been working. Currently, I work at the Technical University of Kenya. I lecture on remote sensing and GIS, and also I do consultancies, as well as now running Women in Space Kenya. So for today, I know I'm supposed to focus more on policy and governance, but I just wanted to talk about geospatial engineering a bit, and I know the previous speaker who was here in the morning, Kelvin, has been able to shed more light on what Earth observation do in the different aspects. And mostly when you talk about Earth observation, is the aspect of using space technology to use it to solve real world challenges, and you can apply it in all ways. So mostly for Earth observation is more about taking or capturing information about objects, phenomena, without physically coming into contact. And of course, here it can be either drones, it can be satellites, and all that. So I'll just talk briefly about the technology and its application. I think Kelvin really touched on its application maybe to the FAO, and how they're using it to solve challenges when it comes to food security or climate change. But you can apply it in so many ways, because it involves the data collection, the analysis, the visualizations, coming up with maps, and all that. Oh, it's not working? Okay, yeah. So I really don't want to get into the technicalities of Earth observation, but I just wanted to mention that you can use it to apply it to different sectors. And for me, as I've mentioned, mostly you can use it for food security, for doing analysis for food security, where, for example, if it's in agriculture, you're able to, okay. Yeah, so then I just touch a bit of saying the drone mapping, where you just now also still collect images, but then you're able to use Earth observation applications to do or to have apply it in different sectors. Okay, it can be either in environment, it can be with trying to monitor the changes in climate and all that. You can use it in urban planning, where you take images of, let's say, Nairobi, for example, and then you try and see how has the city been changing over time. Okay, that's one application. The other application, is in forestry management, where you are able to apply or use satellite imagery to we're able to use satellite imagery to monitor forest changes over time. And most of the time when you use these space technologies, then you're able to advise on what you're able to see, maybe from after maybe you create a map, because mostly that's the products that we normally use. And now you can work with policymakers, you can work with governments to ensure that they make, or even institutions, to ensure that they make informed decisions about a particular aspect. Okay, so mostly it depends on that. I kind of explain now that I've been lecturing, sometimes when I speak, I tend to feel like I'm in a class, so I try to explain things that way. But I hope you're able to understand. So then you're able to use satellite technologies to contribute to actually decision making in so many ways. I think the next slides are just also to just show you about the different, maybe you can ask me questions later, because it's just about giving you a preview of everything. But this is how you see, you can see the different maps that we normally come up, and it can tell you maybe the forest has been changing over time, something like that. So there are different analysis that you normally do. So that's like a satellite application. And then, yeah, that's all on climate change. So if you want to see, for example, during floods, like last year in Nairobi, we had a lot of rainfall and there were areas that were flooded. So you're able to get images of that particular area or region, and you're able to do analysis, and you can even do prediction about maybe in the next coming months, maybe based on the climate and based on the rainfall data, you're able to even do prediction. And even now, the institutions are able to come and create solutions even before, or do like mitigation measures. Okay, so this is the power of using satellite technology. And of course, now that we're talking about policies and governance, it's in the aspect of, in as much as most of us are doing tech, we come up with innovations and all those things. Technology is just a tool, yeah? But then we need to understand that policies and governance are also what creates the enabling environment in everything that we do. So we can come up with very big innovations, we can come up with very big solutions and all that, but it's only the governance and the policy that needs to be in place so that we are able to actually implement whatever solutions we come up with, yeah? So yeah, so it's policies and governance that really determine whether the data we collect, the solutions that we come up with are able to be implemented and to actually have the real impact in the society. So we need to ensure that at least in any way that we are, in as much as we are tech people, we need to ensure that also we try to work hand in hand with policymakers, we work hand in hand to influence policy, to influence structures, to influence the standards or the governance that come, especially when we want to now bring these solutions into the ecosystem. Because without these policies, without these governances, then we're not able to really have that impact of the technology that, or the solutions that we're coming up with. Sawa? Yeah. So I think for me it's more just to say, for all of us, like, let's not just focus on what technology can do, but let's focus on what governance and policy will let it do, like it will enable us to do. So I think I can leave it at that, and then I can let the floor open so that if you have questions, so that it can be more of discussions. Thank you so much. Organization called Women in Space. It's called Women in Space Kenya, and our key pivot thing is to harness advocacy for participation. So we run empowerment programs where we work to increase the aspect of female participation, and especially in the space industry. I know for me, it's been from my experience since I joined Technical University to do my engineering, we were only you can always tell with the numbers, right? Like mostly in the engineering departments, in the tech world, somehow the number of women are a bit less, and even as they grow in terms of their career ladder. So for us, it was more to try and fill this gap, and especially when it comes now to the space-related aspect. So then we created this community where we are able to empower each other. We're able to we have mentorship programs where we link mentees to mentors, and then we also, in Kenya, space industry is kind of still growing. When you talk about drones, when you talk about using satellite imagery, it's still very, the community does not have that big idea about it, so you really have to create awareness. So also one of our key programs is to create awareness, to go to schools, from high schools, from primary, go to schools, talk to people about the space technology, about the space career, about aviation, about also, the different engineering, the STEM in general. And also now we try to get into the policy aspect by doing more advocacy on the aspect of ensuring there's inclusivity and all that. Yeah. So that's it. I think. Thank you so much, and it was an honor to speak about policy.
This panel is very rich here. So I'd like to start on this end. Your name and where you are based. Yes. And one interesting fact about you. Or don't you want to hear an interesting fact about them? Don't you? Do we want to hear an interesting fact?
Yes.
Yes. So let's start here.
Okay. Good afternoon. My name is... Good afternoon.
Good afternoon.
I'm so happy to be here, full of in a room full of like-minded individuals, engineers and women in tech and men as well. My name is Esther Kerabo, and I work for KLM, Royal Dutch Airlines, the oldest airline in existence, and I've been privileged to have worked for them for over a decade and counting. So one fun fact about me, or an interesting fact about me, I have changed a fair share of aircraft tires, which weigh over 250 kilos, but I have never changed my car tire. I hope that was interesting enough. Yes.
Hi again. Good afternoon, everyone again. My name is Shalene Chikuzli. As I've mentioned, I am just partial engineer by profession, a drone pilot, and also a founder at Women in Space Kenya. And I've already spoken about what I do. And I think one fun fact, that's interesting. I think I didn't have it in mind. For sure, but I like what she said. But now that I've actually just gotten into the drone industry, I love being a pilot. I know it's not the actual pilot, but I now love flying drones, for sure.
Good afternoon. I think we are really still afternoon. We still have 1 minutes to go. Karibuni sana, or should you be telling me karibuni or us? Yeah, so my name is Faith Odhiambo. I have been flying for, guess how long? Anyone? Anyone to guess how long I've been flying for? Go ahead.
15 years.
Okay. Anyone else?
2 years.
Wow. Yes. How long? 18. Very close. I've been flying for close to 2 decades now. I'm on my 20th year this year. I have 3 kids, 16 years, 13 years, and 6 years. I always like to talk about them. They are what drive, they are the 3 people that drive me most. What was I supposed to say?
Interesting fact.
Interesting fact about Faith. Faith loves to lift weights. I love training. Yes.
Good evening, everyone.
Good evening.
I love to see young people. It's a fresh breath for me. So my name is Guna Gertrude Odhiambo. I wear so many hats. So I work as a flight operations manager, licensed dispatcher, drone pilot. I'm a founder of Women in Aviation International Kenya chapter. I am now diversifying into the space of sustainability in air transport management and doing research in sustainable aviation fuel and even in the field of hydrogen-powered aircraft. Fun fact about me, I love mentoring young people. And I'm looking forward. Thank you.
Good afternoon, ladies and gentlemen.
Good afternoon.
Yes, Lynn Wako. I'm a cabin crew member for Skyward Airlines, formerly known as Skyward Express. I have 2 years of flying experience. I should have let you guys guess it, but yeah, 2 years in the industry. And one fact about me is I can evacuate passengers or this room right now full of people in 90 seconds.
So just to mention, I think I made an assumption that you know who I work for. I work for Kenya Airways as a flight pilot. I'm sorry.
I made that assumption too because I have Air Kenya tag. So I work for Air Kenya Express. Air Kenya is a bush or safari flying airline. So if you want to be a pilot or a flight dispatcher, just don't think about international flying. There's also bush flying.
And those who fly their dreams. So thank you so much. As I mentioned, this will be a very, very interesting conversation. As you can see, the ladies present are ladies who have experience and ladies who are very enthusiastic about mentoring young people. So this is where we are going to start. Yeah. Should I start with interesting ones or should I start with just? Let's start. So how did you get into your career?
The short version or the long version?
The short version.
Well, I think I was born with engineering in my blood. My late father was an engineer. My brother is still an engineer, so I had to be an engineer. And for my love of aircraft, I had to become an aircraft engineer. So, shortest story.
Wow. Thank you. Yes.
Myself was interesting because it was more like by chance. Because for me, when I finished university, I didn't know. I wanted to be an engineer for sure. But when we do normally when you go to the university, they normally like you have to select the courses that you want to take. And interestingly, I was called to do BCom. So yes, so I did BCom for 2 months, and I was like I really felt like I wanted to do engineering. I wanted the tough mathematics. So I said I wanted to change to civil engineering, but then I love challenging stuff. So I wanted to change to civil engineering, and when I went for interfaculty transfer, you know that like when you have to change from one faculty to another. So in the civil engineering, they told me you don't qualify, so you have to find any other engineering, and that's when they told me this course called geospatial engineering. You can go and find out more about that, and it was really interesting because once I found out it's more about geography, about space technology, I was really fascinated, and that's how I got, and that's why I'm here today.
Interesting. You know, for the first time, I also changed from BCom to engineering. I started BCom at UM, and then I shifted to engineering instruct. So when I tell people this story, I get the shock. So finally, I'm getting to see someone that's in my shoe.
Yeah.
Thank you for that.
So So at least now I know who to come for statistics.
Yeah.
I'm currently taking my degree in international management, and statistics is one of those things that I just don't understand. Anyway, I found myself here coming from a hotel background. I was trained at Utani College for 2 years, carrying out front office skills and operations, an intensive 2-year course. Yeah, and then I moved to work at the Fairmont Norfolk Hotel. Back then it was under loan for hotels, and during that time I was lucky enough to come across someone who encouraged me to embark on pursuing my dream. You know, for as VC was saying that most people have this crush at piloting, I think most ladies usually have this crush at being a cabin crew. So that is the same thing for me. So when I got a chance, through someone, I decided to pursue it, and here I am today. Thankful, grateful, still passionate. It's 20 years strong, and I'm excited.
Thank you.
So for me, I was called to do computer science at KU, sorry. And when I was in Form 3, so because I was studying computer science then, so we happened to have a trip to Eldoret International Airport. So when I saw the cargo planes, I was wowed, and I said, no, I want to change to aviation industry. But now I had a task to convince my parents, you know, to shift from computer science to a college to do flight dispatch. So that didn't go well, but somehow I switched the school fees into the dispatch college. And I knew my dad especially just lacked good grades. So I knew I would ace it and give him distinctions. And at the end of the year, because in university, you get your results every year. So I knew at the end of the year, I will give good grades. So I did that, and by the time he knew I was in a different institution, that was it for me. So that's how I got into aviation.
Shots you don't take, yeah.
Okay. So how I came into aviation is I was very fascinated by flight attendants. I always thought they were very cool. And anyone who mentioned they wanted to be, we used to call it air hostess at the time when we were young. So anyone who mentioned they wanted to become an air hostess, I always thought they were cool in my eyes. And along the way, it changed. I wanted to become a journalist. And I'm glad I found my way back to being a flight attendant. And yeah.
Interesting. Thank you so much for that. Now that you've mentioned Kwani, what are they called these days?
We're known as cabin crew or flight attendants, depending on the airline. So our airline we use cabin crew, but yeah, we're all flight attendants and cabin crews. So don't use air hostess.
Where did you get that?
I think probably it has to do with being gender sensitive, probably, so that it sounds like for a male introducing themselves as an air hostess, I think maybe, but now it's flight attendant, let's say, or cabin crew.
Okay,
yeah.
Let's stay with you, please.
Yeah.
Let's stay with you.
Okay.
So what's the biggest misconception about aviation before you joined? At least now we know they're not called air hostess, yeah? So tell us more misconceptions.
I think that the biggest misconception is that it involves just getting onto an aircraft, flying from point A to point B. There is this void that people don't understand that is empty between point A and B. Like people don't understand when you're a cabin crew, there are things that you do between point A to point B. This includes things like handling in-flight emergencies on board, handling unruly passengers on board, handling even death on board, handling children with severe allergies, handling even couples, like counseling sessions. Things have just gone south, and handling people who are emotionally unstable, and you need to have them stay cool because it could quickly escalate into something that is out of your control. So Also handling hygiene, like handling, keeping toilets clean. So we have this misconception that you see cabin crew pulling a bag and in red lipstick or whatever lipstick, and you think it's all good and dandy until your flight passer says, please go to toilet, one left, it needs to be sorted out, okay? And you have 8 hours, 15 hours, we need to sort it out, we need a toilet, we need that toilet to be used. So that is a misconception that I find is really a challenge, especially for the younger people, because when you come on board and you find that this is actually what I have to deal with, within 6 months you find that you're dropping a number of crew because this is not what they signed up for. This is not what they thought it was going to be about. They thought it was going to be about leaving Nairobi at midnight, getting to Paris. We go to the Eiffel Tower, we go shopping and come back. Yeah, so why is this flight passer telling me to do ABC? You know, why is the captain asking that I need to do ABC? So there are a number of duties that are taken up from point B. And in fact, before point A, there is so much that we do on ground just to say boarding is cleared. Okay, so there's that misconception. And we need to understand that aviation, other than the technical aspect of this, the changing tires, the structure of the aircraft, the systems, there is a servitude nature, and that is what the guests flying you see, the servitude aspect of it. When passengers get on board, they don't see that, oh, the tire downstairs, or rather the tire has an issue. They don't notice that, oh, like the screen is askew. They only notice when, for example, the cabin crew is rude, or the toilet is dirty, and all those things. And they will only remember the structural aspect of the aircraft when we hit turbulence, or something goes off, you know, or we have a delay and there's a technical issue, and such things. So there is that servitude aspect, which is really the bigger chunk of what people see as opposed to what we think. Yeah.
Thank you. Maybe you could pass the mic. So staying on that aspect, what is the one passenger story you've ever had to deal with? Like one that you'll forever remain, whether good, whether bad? Tell us about it.
I think kids, interacting with kids, they are very curious by nature. They ask questions, they want to know. They even ask what's their pay. Is they pay good for this job? I guess so, yeah. So yeah, I love interacting with kids, letting them know what the job is about, interesting facts about it, and yeah, them telling you you're an inspiration to me or I want to become a cabin crew is really good to hear.
Thank you. Maybe we could hear a little bit more from KQ because of the 20 years.
Okay. I have so much that I can say, but I think I want to go more on an emergency that I had on board, which was a death. I'd like to talk about it just so that we understand how humbling flying can be. Humbling in the sense that once you're in the air, you're all equal, whether it's the pilot, whether it's the CEO of, whether it's a VC or whoever is on board, we are all equal because it's about life. Flying is the safest mode of transport, but again, survival rate is very slim in case you have an accident, yeah, according to the facts. So we had this guest who was not well. We usually have something called passenger medical clearance, which means that if you are unwell, because we also have medical tourism. For example, we have many Kenyans moving from Nairobi to India for medical purposes. So for them to be able to fly, being that when you're flying, there's a different cabin environment, we need to clear them for flight. So they go through the procedure, you see your doctor, after your doctor, then they forward the medical report to our doctors, who are now looking at the medical report in terms of the cabin environment. Once they are cleared, then they come on board, and we also, as the people at the door or the flight passer, you check to confirm that this person is actually fit to fly. If you are not sure, then you can call again for a second opinion and ask for further advice. Otherwise, then you clear. This particular was okay, you know, he was cleared, and in my view, in my judgment, I still believe that he was fit for flight. So he comes on board, and during the flight he doesn't have much, approximately 1.5 hours into the flight, we start noticing a change in that he was visiting the toilet more often, and I was concerned that this is not going too well. Anyway, we kept checking and he was fine. Approximately 30 minutes before touchdown, we raise, our normal briefing. We need to prepare for landing, so kindly we do what we need to do and we start. So I nudge him to wake up and I notice this is not right. So I nudge him again and this is not right. So anyway, short and long of it was that he was unconscious and unfortunately we lost him. We tried to do our CPR, we tried to do what we could do, and it was so sad for me especially because I remember when the doctor, usually we page for a doctor on board to come and assist. And when we paged for a doctor, there's a way you communicate and we also are trained to read body language, and when I looked at her, I could see that, okay, things are not so good. So she told me, it's okay, Faith, you can stop CPR. And I remember saying, no, doc, we need to still fight, we need to still go on. And I kept until she tapped me, she was like, no, Faith, stop CPR, time of death, and she declared. Maki, by that time, the captain is also calling me, Faith, am I cleared to land? So he's ding-donging, and this is going on. My crew are asking me, there's so much going on. So anyway, we secure him, we secure the body rather, and I advise the captain that we have lost him. So of course there are also those things that they need to consider so that we don't alarm the other guests. There are those procedures that we follow so that even as he's touching down, he's cautious enough to avoid, let me not go into details, but yes, so we lost him. That is one of the things that I remember. Just to show you that it's a very humbling job. It's a very, very humbling job. Anything can go south, anything can happen. So that when you decide to embark onto this profession, because I notice some of us come onto it and we have this aspect of, let me say, arrogance to some extent. That's not the case. It's not the place. It's a very humbling job.
Okay. Thank you so much. Thank you for sharing that. I mean, that was very powerful, especially the fact that it's a humbling experience. You guys are heroes for trying to save a life. So thank you for that. Now, let's move. Yeah. So tell us, how's the managerial position? Okay, no. Take us through the life of an operations manager as a woman.
So, you work with different people, different age groups, so they are Gen Zs, millennials, they are boomers, so it's a mixed group, and we all come from different cultures. But one thing that helps us to bridge all this is understanding the job. So before you expect a colleague to deliver in a certain manner, in aviation we have SOPs. So SOPs kind of puts you all in a level ground. So you are not witch hunting him or favoring one or the other. So the SOP is quite clear what the goals that are set and the expectations, and where there are challenges or there is need to guide. There are clear guidelines on how to come in as a supervisor or a manager, so that I'm also not hoovering over or micromanaging. So you give each and everyone their space to execute the roles because they have their JDs, but then allow them sometimes to make mistakes because they learn from it, especially when you're onboarded as a new staff. So of course you're trying to get your baseline, but then you end up maybe missing a step. So if you miss a step, in aviation we have a just culture. So if for any chance you are supposed to carry out an activity and you miss it, it's a safety net, so you miss it, somebody else misses it. Then you realize, so you report. In aviation there is no assumption, because assumption could be catastrophic. So you report that in good time so that we mitigate. Sometimes it's a gap within the policy. So in my role as a manager, I can say in aviation, there are standards that are in place. So that way I'm guarded in a way that there's a clear line between the supervisor and your line staff. Yeah, who say that.
Thank you so much for that. Thank you for sharing that. So maybe we could come to you, Ms. Esther. Given that you are an operations in the maintenance space, yeah. So and you are an engineer. Could you take us through maybe some biasness that you face in this space, and also you are in a managerial position, and just to talk upon what she has mentioned, are there biasness that you faced, and yeah.
When it comes to biases, especially as a female, of course they are there because I'm in a technical field where it was perceived to be male-dominated. The biases are assumptions where somebody comes in and they question who you are, and they question who you are before you actually even introduce yourself. So I have an interesting story. So once I was on shift working on a particular aircraft, and the flight crew, the pilots, asked for an engineer to come into the cockpit. They had a problem. So I went there, and as soon as I opened the cockpit door, the statement that was dished out to me was, "Oh, are you the nurse?" And I was like, "Okay." They were like, "No, but you just look like you could be a nurse." So I'm like, "Yeah, well, I'm some sort of nurse. I cannot fix people, but I can sure fix whatever is wrong with the aircraft." So yeah, these are the biases that you need.
Ooh, round of applause for that. Thank you so much, Miss Esther, sorry. So maybe we could come to you, Ms. Charlene. Given that you have founded this Women in Space, how do you handle, how do you handle situations in stress situations? Because I believe that these situations do come up in your space of work.
Yeah, so as I've mentioned, Women in Space actually it's less than 2 years old for sure. It's just an initiative that recently started, and I would say because it's not fully yet like a full organization yet, but it's a community of women, and even not only women but also men. So for me, how I managed to even like run it, I don't do it alone. I'm not the only founder, so I have one more co-founder, but also whether it's a community or an organization, you need to always have a team so that you're able to delegate tasks. You're able to, because I'm only, let's say, I'm able to do some certain tasks well. Maybe I can coordinate activities. I can. When we go for mentorship programs, I'm able to speak and engage the audience. But then also there are other different elements when it comes to running an organization or a community or any other aspect. So you always need to have a team around you that you're able to delegate, you're able to work with them, and also that's how you try to reduce the pressure, because if you also always want to do everything by yourself, then definitely that's where the pressure will amount to you. Because for example, I lecture at the university, I do the other things. And then I also on top of that, if I only become the only person running an organization, then it's gonna be hard, because you have to, let's say, organize events, I have to, be the one who is on the social media trying to ask people to come, I'm the one to talk, you can't do everything alone. So having a team is what, and I know of course everyone here, always you need to have a team around you so that you're able to at least reduce the pressure and ensure that also the work that you're trying to do has the impact that it requires.
Okay, thank you for that. Thank you for sharing that. So maybe we could move to Ms. Yasmin. I have 3 questions, 1-word answers, okay? First flight ever and destination?
Malindi.
Ooh.
Yeah.
Date and Date?
I can't really remember the date. I just remember the destination. It was an afternoon flight. I was very nervous. I haven't taken a flight before, so I was very nervous. I didn't know what to expect. So the minute the aircraft closed, I knew there was no escaping. I just had to face it.
Were you going for sabotage?
Yeah. This is an observation flight. So after training, we do something called an observation flight. You sit in the cabin like a passenger. You observe the crew doing their job, so you know what to expect when you start training on the job.
Awesome. Favorite aircraft?
Dash 8-100.
Hey! Biggest travel fail?
Sorry?
Biggest travel fail? Like, yeah, which you know, even if it's just you who knows what happened.
Can you think about it?
Yeah. Okay. Thank you. Okay, so we can move to Miss Odhiambo from QQ again. So there's this thing we've heard about cabin fever. Yeah, where people, you know, entanglements here and there. So how has it ever affected you getting into relationships? Would you recommend, for example, dating like a pilot? Or maybe could you just address that situation, because we hear about those situations a lot. Yeah.
I think the most important thing about being a woman in aviation, first of all, is to understand who you are, to know what you want out of aviation. Because then if you not have that clear in your mind, then you'll get lost. Flying is, I call it a fake life, very fake and very fast. Because, for example, today I live here, let's say, for example, I'm in Accra for the next 5 days. And the only people that I'm seeing are the so-called pilots. And you're very new. They have the money. Accra, we are based next to a beach.
I'm even tempted.
Exactly. So there's beautiful weather, you're young, you look good. I mean, nature will take its course. So it's up to you to determine exactly what you want and what your focus is as far as aviation is concerned, because then you will find yourself quickly in and out of things that you're not too happy to be in and out of later on. Because again, when we are outstationed, we also have a code of conduct in the sense that you're supposed to behave in a certain way. And if these things go out of control and the report goes back to the company, then it becomes a problem for your staff number, meaning you may lose your job. So I'm personally a married woman. Been married for now, 23 years. I started early. But it is not easy being in a relationship when you're in the aviation industry. You really need to have an understanding partner. You need to use technology, use what you have to make things as open and as accessible as possible, so that they understand that when you're going out there, even if it's your pilot husband or pilot boyfriend, they know that you're out there on duty, not doing anything else. But really the thing is knowing yourself, understanding what you want from it and going for it. Otherwise you can easily get lost. And we are seeing a lot of that currently, a lot of it. It is so sad because at the end of the day, I think women, we tend to bear more of the brunt as compared to the men. Yeah.
Okay, thank you. So I can date a pilot.
Absolutely, absolutely. We have wonderful, I'm not saying that pilots are bad people or people in aviation are bad people, but it's just that what do you want, even if it's in that pilot, is that pilot, does he fit, or does that flight attendant fit what you want or what you desire for in a partner? If that's a yes, then by all means go ahead. And by the way, it's not just in aviation that these things happen. Yeah, even in the offices, these things happen. So it's just that probably we have access to a hotel, we have access to drinks, we have access to all those things. But to be honest, these things are happening around us as well.
Okay, thank you so much. So now I'd like us to do a round because I see the MC is looking at me, unfortunately. So I'd like to start with you, Ms. Kirago. What trends would you recommend the young guys getting into for as we are aiming to shape the future of the aviation field from your perspective, as an engineer?
This is tough, but what I can say simply is if you're passionate about something and if that thing is engineering and you're in the aviation field or aerospace, please don't think that you're too minuscule to take that chance. If I did it, oh my goodness, and I had no role models going into it because I started off, some over 14 years ago. Please take that leap. It's for everyone who is curious, everyone who is willing to learn and can work in a team. So nothing is too small for you. So
Thank you for that. Yes, please.
Same question.
What trends do you see shaping our future in the drone space?
Yeah, I think I would say looking at the technology aspect, of course, the aspect of how AI is coming about, trying to learn, being very upskill about the different technologies that are coming up, especially right now it's AI, there's in research or in any industry there's an aspect of using things like ChatGPT or anything, but just the aspect of you need to always have that upskilling where you try to get in touch with the technology. So things like AI, we should try to be up with it. And of course, the other thing, in as much as we are technical people or you're just engineers or aerospace, in the aerospace community or profession, you don't have to just focus your life on that. I think for me, it's always empowering and encouraging people to diversify your portfolio. You can be in mentorship, you can empower people, you can work with young people, you can do other things apart from just focusing on one thing, because it also gives you exposure, it makes you learn so many things. So that's what I can also talk about, the aspect of leadership and maybe mentorship here.
Awesome, thank you. SP?
The same,
yes, same question, trends in your space. Yeah.
I think for in the industry, the one thing that I'd like us to focus on is mental health, because when you are a cabin crew, your mental, let me say, emotional intelligence and social intelligence is of key. For example, we work, today I will see, let's say, Charlene, then I'll see her next again in 6 months. So every day you're forming a different type of team. You could be going to the same destination, but it is a different flight every day. Even if it's the same KQ761, it's going to be different every day because of the differences in teams. And teamwork and synergy is key. So if you do not have a good space mentally, it can really take a toll on you. And then figure out ways of venting stress. For example, I told you earlier on that I lift weights. I love lifting weights. It's a way of taking care of my mental health, because when I get on board and all that pressure comes at me, I am better placed, I am better prepared to handle that, because I have avenues of letting out stress, which is as opposed to probably going for a glass of wine or a glass of champagne, which I feel that after that you still have the problem pending there. So I think mental health is something that, as much as it seems like it's being said, just being passed around, but it's key in our.
Thank you so much.
I would like to borrow what the VC said, because that really worked for me and I've seen it consistent. Craft your path, believe in it, work on it, be consistent, disciplined, form a tribe or a community, if I must say. Coaching is good, mentorship is perfect. So don't walk alone. So try and join the aviation or aerospace clubs within either your institution or Women in Aerospace Kenya, Women in Aviation. There are also other professionals. And even for us, we invite men. Our patron is a man, so that then we work together. And in that, I can tell you a beautiful story of young people we started mentoring at a very young age. From primary, high school, they're either now flying engineers. As I'm talking now, I have 2 engineers and 1 pilot representing NGAP in South Africa by ICAO. I look at them and I say, these were the young girls that we mentored. I am happy. I feel like I have achieved. Because you are here. We are not thinking about the next generation. You're already here. We are ready to pass the mantle, to guide you where you need guidance, and to let you flow like a river. Thank you.
Thank you.
For me, I'd say this representation really matters. When I first started, I struggled. I kept searching online, hijabi cabin crew. I couldn't find anyone. Because I didn't think there was space for me in this industry, and it's something that I was very passionate about, and I took it upon myself, went online, TikTok, and I talked about it, and you see Muslim girls like me asking, like, are you sure I can wear hijab? Like, oh, I've been going through online, I've been searching, I've not seen anyone who looked like me. So it's really nice that I'm inspiring my fellow Muslim women out there, and I'm very proud of that. And yeah, I think representation really matters in this job.
Thank you very much. So we've not forgotten your answer. We have
I'll answer it privately.
Okay, thank you. So maybe we can start with you, Ms. Shirley. What's the one question you thought I'd ask you that I haven't asked?
One question that you haven't asked. One, mostly maybe what are the challenges, but she's already talked about it, like what are some of the challenges that maybe women face in the industry? Yeah, but I think we've already talked about it, so yes. I'm glad it was that.
You sure you don't want to top up? Just
not really, but I wanted to just touch on the aspect of, and just say that when you talk about women and we want to address about the women aspect, it's not just that we are discriminating the male or anything, just that we see for sure, as she mentioned, underrepresentation, and also mostly the cultural or the societal bias. So it's about, when you talk about and we want to emphasize the aspect of gender or inclusivity, it's not only to say that we want to tick the diversity box, we want to tick the female box, but it's more about ensuring that we have equal spaces and also representation in such a way that we all bring different. Hello. Yeah. So that we all bring our different ideas, our different perspectives. So ensuring that there's representation maybe for the female and also the male maybe in equal measure, then you ensure that there's actually ideas are there, different perspectives are there, and also, yeah, so it's about ticking that box.
Thank you. Back to you, Ms. P. There's this misconception about beauty standards in the aviation space. Could you cover that briefly?
So as I earlier on touched on, I mentioned that sometimes as cabin crew, or rather when you get the job as cabin crew, I think there's that aspect of some arrogance, like we feel that being a cabin crew is all about beauty, but as I mentioned, it has so much, there's so much more. You're more of a servant, to be honest. You're more at the beck and call of people sitting, people who have paid premium to be served by you. So if you ask me, it's a good thing to be beautiful in the aviation industry, but I think that is just not enough. it's not enough. You need to do more to be able to carve out your space in the industry. Yeah.
Absolutely. So you can show up without makeup and you'll get the job?
Unfortunately, you cannot. I will tell you to go to the bathroom and put on your makeup. Yeah, the standards require that we put on the makeup. It's part of our uniform, so I personally hate makeup. Yeah.
Yeah, good thing you're beautiful, so I understand. Okay, thank you. So we'll just do one last round of one-word advice to your younger self. Yeah, we can start with Miss Yasmin.
I'm super proud of you.
Oh.
Everything will turn out just like you dreamt, because mine did.
Amazing, amazing.
Ask questions. Be bold and ask questions. You never know. The only thing that someone can say is a no, but they will not beat you, and it can always open doors for you. Yes, learn to ask questions.
Amazing. Thank you. Miss Esther.
You will interpret. Yeah. You don't see so many people like you, females of course, but you will interpret, you will fit perfectly.
Okay, thank you. Back to you.
You will live your dream.
Amazing. Round of applause, round of applause. So, I have gotten a very slight request. So, Miss Faith and Miss Yasmin.
Yes.
We need to feel like we are going to Paris right now.
Take us to Paris.
Take us to Paris.
Okay. So, would you like us both to brief you, or would you like us one person?
How do you do it?
The welcoming announcement, or we do welcoming announcements. We also have other announcements in both, but since you're saying we take you there, definitely the welcoming announcements.
Okay.
Yeah.
Okay.
So, do you want to do that? Okay. Hamjambo mabibi na mabwana, karibuni kwenye ndege hii. Safari ni nambari 112 kuelekea mjini Paris. Muda safari yetu unakisiwa kuwa masaa 8 na dakika 50, tukiruka umbali wa futi 40,040 kulingana na usawa bahari. Kwa muda usio mrefu tutaonyesha filamu kuhusu zana za usalama zinazopatikana kwenye ndege hii. Tunaomba nyote kutizama filamu hiyo kwa makini, hata ikiwa wewe ni msafiri wa mara kwa mara. Jina langu ni Faith Odhiambo na mimi ndiye mdomo msimamizi. Ningependa kuwashukuru nyote kwa kuchagua kusafiri nasi jioni ya leo. Asanteni na karibuni. Bonjour, mesdames et messieurs, de la part de Kenya Airways. Le commandant Koki Mutungi, j'aimerais vous souhaiter la bienvenue à bord de vol numéro 412 à destination de Paris. La durée de ce vol sera 8h50 et l'altitude sera 40 000 pieds. Dans un instant, on va vous montrer une vidéo sur les mesures de sécurité de cet appareil. Et nous vous prions de rester attentifs, même si vous êtes un voyageur habituel. Merci pour choisir de voyager avec nous et nous vous souhaitons un vol très agréable.
Pass through.
I do the English version.
Can you pass through India?
Good afternoon, ladies and gentlemen. On behalf of Sky Airlines, it's my pleasure to welcome you on board our Dash 8-100 aircraft flying to Paris via India. Our captain today is Captain Kanina, being assisted by First Officer Ahmed. Flight engineer is Ben. My name is Halak Yasmin. I'll be your cabin crew today. Estimated flight time to India is 1 hour 10 minutes. We shall be cruising at an altitude of 25,000 feet above sea level. Safety regulations require that I point out to you the safety features we have on board and how to operate them. Please now pay attention as I demonstrate.
So since we're going to Paris, we just finished off, right?
Yes.
Yeah. Okay. The health authorities of our destination require that we spray the aircraft with an insecticide. We will be doing so shortly. It does not contain any harmful substances, and any discomfort you will experience will disappear quickly. You may also cover your mouth and nose with a handkerchief. Safety regulations require that we dim the cabin lights for takeoff and landing during dark conditions. We will be doing so shortly. If you wish to continue reading, you are requested to use the provided individual reading lights. The control panels are located on the remote control. Thank you for your attention, and we wish you all a pleasant flight.
Amazing. Thank you. Didn't we get to Paris? Yes. Didn't we get to Paris? So one last round of applause to our panelists. Thank you very much. We appreciate you. Yeah, so your host or your moderator has been Ms. Joy Mute. With a little practice, yeah? Sure. So thank you very much, really appreciate it. My name has been Joy Muntet, and I am from Strathmore University, currently a 5th year in doing electrical and electronics engineering.